Let me use your. All right, this is a test. Oh, okay, no good. All right, live stream. Can you hear us? Yes, no. Hello. Yeah. Can you speak louder? Yeah, I'm kind of being quiet.
Welcome, everybody. Thanks for coming along Saturday at DevFest here. I just want to open this a little bit by saying that we're an inclusive community, developers and designers, all levels and grades, and so we have like a very simple code of conduct, and that's like just be excellent to each other. So if there's anything that we can help with, like the organizers, Margaret, myself, Clive, Jason, and Brandon, just like say hi to us, and we can pretty much sort most stuff out. And so, as part of being a diverse community, we were like really lucky in 2015 to add some women organizers to our group. So, as a good sign of that, I'm just handing this over to Margaret because she organized this DevFest. Thank you, Margaret.
Thank you, guys, and thank you, everyone. So, welcome to GDG Seattle DevFest 2015. Are you guys excited? I am. I would like to thank Women Tech Makers for their support of the DevFest this year.
I'm sorry. You can step around. No, yeah, you're.
Okay. I would like to thank Women Tech Makers community for their support. Women Tech Makers is a community for providing visibility, community, and resources for women in technology. Whenever I go to a tech event or meetup, I look around me. Typically, there are 2 or 3 women out of 100. But today, look around you. How many women are there? Probably 20, 30, right? So this is incredible. Anna Redmond, who is an organizer of GDG Seattle, she has put in tremendous effort to also make this happen. She's going to organize a meetup in January to help women become better public speakers. So I will provide details later on today for women to sign up with your talk proposal if you want to become better public speakers. So here's the schedule for today, just high level. 9 o'clock or shortly, we will have breakfast. And then we'll kick off with Cloud Spin by the Cloud team, talk on Firebase and Android design support library, then runtime permissions. Then we'll have lunch at 12, collabs and office hours in the afternoon, which I will provide details later. Then by 3 o'clock, please submit your app show and tell. And then 5 o'clock, we will have 5 minutes per app for you to showcase your app, whether you're a beginner Android developer or you learned something today, how to use the design support library for implementing material design or implementing runtime permissions. And then at 6 o'clock, we'll have after hours, which is optional at Redboard. Now, let's kick off today's event with Cloud Spin. Please welcome the Google Cloud team.
All right. All right, guys. Hey, how's everyone doing? Good. Good. So we're running a little late. So what I'm gonna do is go through really, really fast. My 45-minute presentation is 15 minutes. So if you have questions, please feel free to come back and ask me. Right? So I'm not going to cover everything in 15 minutes. So my name is Sandeep. I am a developer advocate on the Google Cloud Platform team. I am based out of San Francisco. All our Seattle folks are not in Seattle, which is really funny. So I came up here. So today I want to talk to you about, I don't know if you can put a camera, about Cloud Spin. So Cloud Spin is the story of how we got all matrixing in the cloud. How many of you have not watched The Matrix? So you guys all know the scene with Trinity, and she kind of jumps up like this, and it's the coolest thing ever in 1997, or whenever that came out, and it's still cool today. So we want to kind of emulate that using a lot of cloud technologies. And the idea is, I'm the CEO of a fake startup, right? So my goal in my fake startup is not to make revenue or make my users happy, but just to build cool products. That's not what startups do, but fake startups do that. And my goal was to use as many cloud products as possible in a cool demo. Again, that's not what real startups do, but fake startups do. But like a real startup, yes.
You can actually share your screen in the Hangout, so I see your camera, but not you.
All right, but like a real startup, what we want to do is actually build an MVP in 3 weeks. So everything you see the outside that we built was built in 3 weeks. And this is what we came up with at the end, right? This is Google Cloud Spin. It creates a 180-degree moment in time, bullet time, you can say, of a person doing something cool. Pretty cool stuff. So how the heck did we do that? That is the story that we're going to go through today. So going through it really fast, the cameras are around in an 8-foot arc. Guy's in the middle, marketing. And the guy jumps up. We take a snap somehow of the guy jumping up, and we stitch it all together into a GIF. But that sounds really easy, but the truth was, once we started doing this, it was really tricky. How would you guys do it, right? It's a lot of ideas. You can use DSLRs and use very synchronous timing and things like that. But we wanted to do something a little bit different, right? So what we ended up with was videos. Why? 30 FPS is kind of like burst mode on a camera, right? 30 frames per second. So the problem with Android phones is you cannot, say, take a picture at this exact millisecond. And for this to work, you need about 2 to 3 milliseconds maximum delay between the phones. So with an Android phone, you cannot trigger it because there's a whole operating system stack that you have to go through, right? So video was our solution. And what we did is we needed to identify the frame somehow. We tried timestamps and flashes and things like that. But the easiest way that we came up with was use an audio marker. So what we do is we take an audio signal, flip it around, and turn it into a microphone signal. And we had a lot of electrical engineering that went into that. And we said, screw it, we're going to use off-the-shelf adapters. That worked a lot better. So this is kind of what it looks like. I'm not sure if you guys can hear that. Do it one more time. So you see that little beep? That is our audio signal. Okay. So now we have all these phones, and they've all got these little beeps, and they're recording video. So from all these different angles, you can stitch them together, right? Now the question comes, how do we actually do that? And that's what we really use the cloud for. So this is the architecture. Everyone must memorize this architecture because you'll be quizzed on it. I'm just kidding. But this is kind of what it looks like, and we'll be going through this in 10 minutes. I'm not sure how I'm going to do that, but we'll do it. So what we have is all these devices. They upload videos. We somehow get notified that these videos are uploaded. Then we start extracting those frames out. We stitch them all together, and then we come out with our GIF. So first question, how do we actually coordinate these 19 phone cameras? Outside you see 11 because it's the mini rig, but in the real big one it's 19. So how do we coordinate all these, do all these things when we say go, right? No, seriously, how do we do it? What do we need? We need all these things to be automated, right? We don't want to manually set ISO and shutter speed per phone, and when a camera crashes, we got to know which one crashed, which microphone is using, the internal mic or the external. We need to use the external mic. We need to say start recording right now, so all of them start recording at the same time. This sounds like something Firebase would be really good for, and that's what we use it for. So Firebase, and you guys will do a code lab today, is our app's backend, right? So it stores all our data and syncs it in real time. You can think of it as a giant JSON object in the cloud that all your devices share, which is really cool. So this is some Android code. Basically, we create a reference to our Firebase. We get all the cameras configured down. And in our tablet app, we can see the status of all our phones in real time. And you can see this is a Firebase tree viewer that comes with your Firebase by default. You can see all the data that we've set there. When you click Start Countdown, it sets a timestamp, and the timestamp gets sent to all the phones. And so they start, at that time, they start recording. All right. So now we have them recording this video. So we have 10 phones, 20 phones recording 100 megs each, right? Or 10 megs each. Now that's a lot of data for every single picture, right? So it's 100 megs per picture. Got to upload that somewhere. So we need something that can store a large amount of data because, you know, Cloud Spin's going to be super popular and it's going to be everywhere in the country. So gigs and gigs of data. We need immediate access. We cannot wait for it to be available, right? And strong consistency. And of course, notifications so that we know that it's ready to be processed. So we use Google Cloud Storage. Basically, it's our place, a central repository for, you know, big files, things like that. Videos are perfect for it. It's an object store, so it's like files, pictures, videos, text files, things like that. Rather consistent, and gives you change notifications. So I will go through this. We are using standard storage. We also have Nearline, which is great for backup. Let's skip through that. So what we do is every time a video gets uploaded to our bucket, we get a little webhook that gets sent out. And we can do something with that webhook, right? So here we go. And so what it kind of looks like, the JSON object that it sends in our webhook message. OK, so this is kind of more Android code. So you can see here it's going to take that video file and then insert it into cloud storage using the cloud storage driver. Easy stuff. Some cool thing about cloud storage is it does edge caching. So if we have Cloud Spin running across the world, our images are actually stored by default in our CDN, right? So you don't have to set up CDNs or things like that. They're automatically cached. All right, so now we have those notifications, and I'm going really fast, but just to sake of time. So we have those notifications, we've got to do something with them. And what do we need? We need to be able to handle those HTTPS post requests that are coming from cloud storage, simple authentication, and then we need to be able to kind of push and pull these tasks into a queue so we can actually do something with them. And for that, we're using App Engine. App Engine is a super easy platform as a service. You just write code and you go. No servers, no any of that stuff to worry about. Java, Python, PHP, Go, and Docker as well are supported by App Engine. So the cool thing is we can just write our code. Of course, Francesco wrote it, so it's in Go, and we can proceed with our life. So the cool thing is it auto scales. There's no servers to manage. It just works. Exactly what we need for a 3-week sprint. All right, so now Cloud Spin is going to get really popular, right? We have stuff in New York, San Francisco, Tokyo. It's just going worldwide. OK, we need to start scaling up our system. We need some sort of messaging shock absorber, right? We need a way, if we get a ton of people using Cloud Spin at once, we cannot have like error, error, error. We need to buffer those messages. So messaging really is a shock absorber, right? So it gives you more availability and more throughput. What that really means is we buffer a request during outages, so we never actually drop anyone's request. And you can spike out the request rate, so you're not spinning up and down resources unnecessarily. So these are our pipelines. What we really need is asynchronous messaging. You know, we don't want to block on these messages. Pull subscriptions. We want our extractors to be able to pull work down when they're ready. So there's different things pull and push. I'm not going to go through that. And what we used was Cloud PubSub. So Cloud PubSub is our real-time Google scale messaging subsystem. And basically what it does is it allows you to have multiple subscribers and multiple publishers all talking to each other in a globally distributed queue, which is really nice. So here's like an example. We have a PubSub topics, and we have a bunch of publishers publishing to those topics, and we have multiple subscribers per topic, right? And you can have N on each side. So you have multiple publishers, multiple subscribers, and multiple topics. So it's a very flexible architecture. Right? And who can pull and push? Basically anything that can talk OAuth 2 or HTTPS, which is really nice. It's pretty much everything. So here's what we're doing, right? Our app engine is going to push, hey, new videos to process, new videos to process, new videos to process, onto this extractor topic. And then we have all our extractors spinning up in the background and pulling it. So depending on the size of the queue, we can actually spin up and down more extractors as needed, right? So we're not spinning up resources if we don't need them. So meanwhile, at our secret startup lab in New York City, first prototype was pretty cheap and scrappy. We didn't have measuring tape, so we used caution tape instead. Yeah, apparently caution tape has a measurement in some way, shape, or form. And then selfie sticks. They don't balance. No. Drop phones, bad. So this is what it kind of looked like, and this is what it kind of looks like outside, where you guys can try it out. A bunch of phones on tripods. This is an intern. He's figuring out why the light won't work. Can you guys figure out why the light won't work? Yeah, he's trying. It's okay. All right, so we got this. We got our hardware kind of working and stuff. We got the pipelines pushing in. Now we got to actually make our GIF, right? So we have all these jobs on the queue. How do we extract that frame? So we need to somehow find out where that beep is and pull that frame out, right? So this is what we wrote in Python, because Python is Python. And basically we're using a library called MoviePy. We're just splitting it up into frames and looking for the one that's more than 4 standard deviations than the mean. So all we're doing is amplitude. We're not doing anything fancy here. But where do we run that? Where do we run that code, right? So we need some sort of long-running service so we can pull multiple videos down. And video does take time to process, right? We also want to be able to scale it on QDev and act as a secure pub sub subscriber, which is not very difficult. And it has to be simple to develop, right? We only have 3 weeks. So we use Google Compute Engine. That's kind of the obvious thing. It's our infrastructure as a service, which means you're running a VM. The cool thing about Compute Engine that I think is it starts up really, really fast, and it's sub-hour billing, which means you pay per minute, which is perfect for our use case because we're spinning up and down resources, and we don't want to overpay. So the old way of doing this would be having an on-metal machine, bare metal, and then just running all your apps directly on that giant machine, right? But no one does that anymore. Everyone basically uses virtual machines, right? And that is the way that's kind of very popular today. And that's what Compute Engine really is. But the new way, or not yet, hold on, one more slide. So the first prototype we did, we just had 1 job per VM, and we just like crank up and down our VMs. That's kind of crazy. You don't need a full VM to run a little video extractor, right? But how do we bin pack a little bit better? So the new way, of course, is containers. How many of you have heard of Docker, things like that? Good. Every time I ask that question, more hands go up, which is really awesome. So containers allow us to run multiple apps on the same machine without conflicting. They give us process isolation and cool things like that. Google, of course, has Kubernetes, which is our open source project. And our commercialized version of that is Google Container Engine. So we switched our workers from running on straight Compute Engine VMs to a Kubernetes cluster. And with that, we got basically a 3x utilization increase for free, right? And it's way easier to manage our app because we don't have to worry about VMs. We just like scale up pods using command line interface. Super easy. So I really think that Container Engine is that golden star between flexibility and developer efficiency. That App Engine is super easy to develop, but you do have some limitations on what you can do. And Compute Engine, where there's no limitations, but it's harder to develop. You don't know like operating system stuff and ops and things like that. While Container Engine is kind of like Goldilocks in between the two. All right, so we've got the frames extracted out, and we can stitch them together using another queue. Easy stuff. And now we have all this stuff. Now, the cool thing is we have a cool UI that you can see all this happening in real time. And how do we do that? How do we know that we're ready to display it back to the end user? Remember, our app is running on Firebase, so why not use Firebase again? So Firebase is actually being triggered every time an event goes on in our pipeline. And it's going to show us what's happening in real time. And we don't need this. Instead, I will do a handout. It's called a remote live demo, because live demos are not scary enough. I'm crossing our fingers. video call. So I'm doing here we go. Hello, Kathy. So I'm going to refresh this. So this is what's happening over there. I'm just going to refresh this page real fast. And Kathy, are you ready? So Kathy is going to trigger Ian, who's standing in the middle with a bunch of stuff. And Kathy, can you show Ian? Thank you. And when you guys are ready, go for it. I hope they can hear me. All right, so you can see the phone went yellow. That means it's ready to, and blue means recording. And she'll say jump, and he will do some cool jumping thing. And yeah, it's okay. It's okay, man. So now all the phones are uploading to Google Cloud Storage. You can see the input bucket being triggered there. All right, cool. And now they're processing, which means that our compute engine has gone to the, it's going too fast for me to talk. It's gone to the pub sub queue, pulled those jobs out, extracted those frames. The frames are going to be extracted, sent to another queue, back to Google Cloud Storage. Then our stitcher is going to take all those little individual PNGs, stitch together into an MP4. MP4s don't work on Twitter, turns to a GIF, and the GIF gets posted back to Firebase. All right. Now, who wants to go try it out? That's the question. All right, cool. So we do have it set up outside. You can go check it out when you want to. So just to recap real fast, because okay, so remember all our phones, we're going to cloud storage. We process those notifications on App Engine. App Engine is also doing the Twitter and emailing for us. We went through all the stitchers and the extractors using the pub sub topics and our compute engine, container engine clusters. We went back to input buckets a few times to do all the GIFs and PNGs and all that good stuff, and Firebase to do all the visualization and our app backend. And we'll see those little icons are very, very important because everyone understands what this means, right? But anyway, special thanks to our demo builders, Brett, Frances, Kathy, and Ray. Kathy's right there. Say hi to her. They really did build this in 3 weeks. That's not like we didn't make that up. It was actually built in 3 weeks. I don't know how they did it. I'm kind of impressed. And then thank you guys so much. 3 of us here from the cloud team today, me, Ian, and Kathy. Come ask us your questions about anything cloud. We will be very happy to answer them. Thanks, guys.
Thank you, Sandeep, and thank you, Google Cloud team, Kathy, Ian, and Sandeep. I think we can take a few minute break for you to get some coffee and breakfast. Then we'll come back for Firebase topic.
Yeah, usually I just upload it for or like, well, I upload it to the internet or whatever. I guess it'll be from the
The sensor's always the same. We actually had a problem in Europe getting some other keys. Codes fell apart in the middle of different frames. So extractor things. So you can't really get around that. why we use video. And then because we're using video, we're setting the ISO and shutter speed exactly the same using Firebase. We're like making one click and changing on every component. So that camera status. That's really neat. It is. So you're almost in the opposite of what they're doing, right? Because they're doing outlets. Yeah, it's really cool. I think that the real trick that we want to do is 100% omnichannel. So you can literally go out and buy everything from the store. Exactly. It's very good little thing.
Yeah.
All our classes.
That's a great quick presentation.
Thank
Nice
you.
work.
I super rushed through that. It is really.
Is that site?
I don't know. Brett had the version on this. Maybe. Yeah. I think he did Boston.
Yeah, because it was tough.
Yeah, I went very fast. Usually 45 minutes, and I did 15. So. Yes. Maybe we should just announce that. I'm used to this. And yeah, by the way, so if you want to take a cloud spin, go out those doors and then just walk straight down. You cannot miss it because it's huge.
We will be there. But come over and we'll try to show you. Okay. Thank you.
You want to join like your
Oh, I will.
please do.
Unless you want to use your microphone, use your microphone. As long as you speak loudly, we should be okay. So then the only other thing that's on the side here, like you need to share your screen so I can see the slides. We're good. You are.
On the schedule, it was like 40 minutes or
Yeah,
something.
45 minutes, yeah. This goes from 9:30 to 10:15, but we're running a bit late.
You know, going, how they want you to.
That's fine.
Okay. Yeah, I'll just kind of.
You don't have to fight it because sometimes you take your time. We'll just adjust because I put a little bit of gap between
Yeah.
Whenever you're ready.
Let me check. Jason, are we good with recording? All right. Hopefully you all get some coffee and breakfast, and we're going to continue with our talk of this morning. Ian from the Google Cloud team is going to share with us how Firebase works and how you can use it with your Android apps.
Hi, can you hear me? All right, great. So I'm going to be talking today about Firebase and specifically about kind of creating like real-time mobile apps and in this case, mobile games. So the title of my talk is Real-Time Mobile MMOs with AI, and so that sounds pretty hard. Like, how hard can it be? But hopefully, I can show you that that it's actually not as hard, quite as hard as it looks. So, if this will actually advance. All right. So my name is Ian Lewis. I'm a developer advocate on the cloud platform team. I'm based in Tokyo, Japan, so I'm usually over in Asia. But I visit the States from time to time, and so you can kind of follow me on Twitter and stuff like that if you're into that kind of thing. So how many of you guys are mobile developers or Android developers? So a good number of you. How many are web developers? Okay, okay. So kind of half and half, I guess. So you kind of want to build the next, hot mobile app. So let's say it's a game that has like, millions of users, or and they all kind of like play together. They have to interact and you have to be able to like share that kind of information with your app or with each of the users of your app. So you need to do things like authenticate your players, store data, enable interactions within the game, and a lot more. There's like quite a lot of things that you have to, nitty-gritty kind of things that you have to build into your app. And it's pretty common at this point to like, power these functions with a cloud provider or something like that. But what does that actually mean? So if you're familiar with things like, with Google Cloud Platform or other kinds of cloud platforms, you kind of think of it almost as a black box. But when you actually start getting into it, there's actually a lot of components that you have to start thinking about. A front end, so like static files, HTML, JavaScript. How do you serve all of those files? So then you have to have some sort of business logic, like a business logic processor. If you're a web app person, maybe you run a Ruby on Rails kind of application or something like that. Something that takes some input from the user and writes things to the database and does some business logic. And then you have to actually have a database, something that will store your data persistently, so that it's not lost, or so you don't lose that kind of information between the users. So basically that turns into kind of this like n-tier architecture, and you get like end tiers in your architecture, your database, your backend, your front end, things like that. And so like, even with the convenience of provided by, modern cloud providers, to be able to like create things like VMs and disks and things like that, you still have a lot of moving parts within your application. It can be kind of daunting, especially for folks that are mostly familiar with developing apps on the client side on the phone. So pretty soon your kind of mobile app that you were trying to make, or your game, and so you're really excited about creating all the interactions in your game, but pretty soon it turns into this like big infrastructure project, and you have to like think about all the backend and stuff like that most people don't really want to care about. And so you have to kind of build and test and deploy interfaces for like multiple types of clients as well. So things like phones and tablets and desktops. So like maybe your app supports something like iOS and as well as Android, and then maybe you have a desktop client as well that you can access through the browser. Maybe you have to kind of build and test and integrate all of those, and that can be pretty hard to do. And then once you've set all of that up and all of that works on each of your phones and you have your backend and all of that, you still have to be able to make your app talk or enable your app to talk between the users in real time. Say you're writing a game, you want to be able to have the user A be able to see user B, and when user A moves, then user B can see that, and that sort of thing. So you have to have some sort of real-time interaction kind of going on.
Can you mute sound on your own laptop?
On my own laptop?
Your laptop sounds broadcasting through your microphone over the speakers. It's not in the recording, so
okay.
everyone here is hearing an echo.
Okay, sorry about that. Okay. So that's actually pretty pretty difficult. Yeah, I muted my
Okay.
yeah, I don't know what it is. It's this. Okay, so that can be pretty difficult to deal with. You have to be able to manage the connections and things like that between your app and the backend, and then be able to feed that data like real time into another person's into another client or another phone. And so that can be actually pretty hard to actually get working and get working well, so that the users don't feel too much lag between when they actually create an action and when somebody actually responds to it. And it can certainly be done, but it's really hard. So it would be great if there was something that could just take all of those parts, those moving parts, and just do it for you. And so you wouldn't have to worry too much. You could just focus on building your game and building the interactions with your new game, and making it really engaging. So there has to be like kind of a better way than like reinventing the wheel every time. There's a lot of games and applications and things like that that really want to be able to implement the same kind of features. So there has to be kind of a better way of doing this, right? So that's where Firebase comes in. And it's kind of off center, but so Firebase is a real-time database backend as a service that you can use to power mobile applications. And so what Firebase does is it allows you to connect from mobile and web applications and then have those communicate in real time, as well as have a backend database that is persistent across sessions between each time you actually run the app. And so you can use it as your database as well as a real-time component. So Firebase provides three main features. One is the real-time database that I mentioned. And so the real-time database allows you to, or provides you with storage and syncing. So whenever you save to the database, you can create triggers on the database so that when something changes in the database, that gets pushed to all of the clients that are listening. And so you can, whenever a person changes a particular value in the database, all of the other users can have that synced to their phone and then see it in real time. I'll show a little bit more about like what sort of things you can do with that, and in order to or what that actually looks like in practice. Firebase also provides a user authentication component. So you don't have to worry about authentication and storing users. So you don't really actually have to create a backend to do the authentication. Firebase can kind of do everything for you. And then finally, Firebase provides a static hosting service. So you can host the HTML and JavaScript files on a CDN that allows anybody around the world to access your static files really fast. And so across these, the real-time database, the user authentication, and the static hosting, you've pretty much covered maybe 90% of the bases that you need to for a backend for mobile applications. And so we think that this is pretty convenient to for mobile apps, and so that they can focus more on the application and less on actually dealing with the nitty-gritty of the backend. So here's some examples of how you can use Firebase and what real-time actually is. So in practice, so I can actually click on some of these, I think. Let's see if it'll actually show. So here's an application that uses Firebase, and this actually stores or updates the all of the positions of the Moonies within San Francisco. So there's a backend kind of app that is getting the locations of the Moonies, and it is storing it in Firebase. And whenever that changes, all of the people that are viewing this map can see the Moonies moving around in real time. So with each of these little objects, their locations change, the UI can update automatically.
Moonies is the buses, I assume?
Yes.
What grade does that mean, Brad?
So I did forget where I was for a second there. I am in Seattle. So this is actually from San Francisco. So Mooney is the kind of it's like a municipal bus system. It's really like above ground like rails, like light rail kind of things. But yes, good point. So let's see if I can go back to my. So you can provide it to. You can actually have it have applications that provide like location-based real-time data. So like showing where your friends are, or like showing where particular objects are, like buses and things like that. You can also use it for things like collaboration. So I think this is an app that is used for, oh yeah, this is been played with quite a bit. But this is an app that you can use and play around with other folks. And so if somebody else actually logged into this app, I don't know the URL actually. wv-mobile-demo.firebase-app.com. But if somebody else logs into it, you can actually see them drawing in real time, and can actually see me drawing in real time as well. So those types of collaboration apps, so things like, if you're familiar with things like Google Docs, where you can have multiple people editing the same document at the same time, those type of apps can be enabled by Firebase as well. And then finally, games. So you can create some real-time games where multiple players play at the same time. This is a Tetris game. I make this bigger. And then I actually log into this twice and play myself at Tetris. So you can see that like my one player's board and another player's board can be shown in real time. So you can actually see how you're doing compared to the other player and things like that. And like perhaps if the other player has a score or something like that, you can update that and show that in real time, so you can kind of have that kind of competition and things like that. You know, kind of talk a little bit more about like how you can develop games, more rich kind of games in a second. So yeah, so real time is hard. There's a lot of components that go into real time. It's very engaging to be able to do real-time applications, but the actual implementation is quite difficult. You need to think about things like the transport, the complex transports of how you actually send real-time updates and managing the connections between the machines. So dealing with lots of persistent connections is actually kind of a hard problem. You also have to deal with unreliable networks. So we're talking about like developing things for mobile phones and laptops and things like that. So you could be like on unreliable 3G networks, or like slow networks, or folks are using your app in the subway or something like that. And so you have to think about like what happens when the user gets disconnected, or what happens when the user's latency is really high. What does your app do then? How does it perform? And then you have to think about things like how do you do this multi-platform? How do you do it on the web? How do you do it on Android? How do you do it on iOS? All of these are pretty difficult problems that you have to think about. So let's talk about a little bit about how Firebase works and how you can actually use it to develop an app. So the demo that I want to show is a simple Firebase game. So who knows Android or Asteroids? The game Asteroids. Yeah, so everybody knows that. So this is Asteroids without the asteroids. So sorry. So this is actually going to be a game where instead of shooting asteroids, you shoot other players instead. So this is like kind of a multiplayer real-time game. So yeah, it's kind of like spaceflight. So here is the actual game. Let's see if I can show this on the screen. So here's the actual game. And so I only have myself logged in right now. But if you want to go to like, what is this, sizzling./inferno.firebaseapp.com, you can log in and play the game. And just to illustrate, if I log in twice here, you can see two of my ships here. And you can kind of fight with each other and things like that.
So sizzling-inferno.firebaseapp.com.
Yeah. So like this is going to be the rest of my talk. I'm just going to play this game. Okay. So that's the game. But how do you actually implement a game like that? So here I want to talk a little bit about how you would use Firebase. And in this case, I'm going to be talking about how to do it with JavaScript in the browser, but it's very similar how you actually do this within Android and stuff like that. And if you're interested in how to do it in Android, you should definitely come to the Code Lab later today. So basically what you do first is you create a reference to the Firebase, and then from the Firebase reference, you can get a child object. And so within Firebase, all of the database is represented as a big JSON object. So let me actually show you what that looks like in the management console. And it looks like a lot of people are kind of like joining the game here, so I should go back at some point. Yeah, it's madness. Oh, I'm probably losing badly because my ship is just sitting there. But basically the database is represented as a one big JSON object. So if you're familiar with JSON, it's a very kind of a tree-like format. So you can think of each of the values within the tree-like format as being a key value kind of idea. But you can get things like lists and stuff like that, and you have a little bit more rich data structures. But essentially, it's a big JSON object, and you can do interactions on the different keys within the JSON object. And then you can actually create listeners and things like that on each of the keys in order to connect those to UI elements and things like that. And the management console is actually really, really cool. You can kind of see like which keys are being updated and changed in real time as well. So if you actually drill down in here, you should see some information about a particular ship and where they're moving and what their values are. And these will change like pretty much in real time. Let me push that away. Oh, crap. There we go. So because it's a kind of a JSON tree-like format, you can kind of create a reference to the Firebase. So that'll create a reference to the root of the tree, and then you can do like .child's game, and then that'll get the game key that's underneath that the root. And then from the game, you can do the same thing. You can get child or whatever, and then you can kind of navigate the database that way. So from the Firebase, the game reference, you can then get the players, and then so when you log in as a new user, you can push a new ship into the Firebase. So here within the players list, I'm pushing a new value, and then within that, I'm going to be pushing my ship data. But here, this is actually where when I log in, I'll create a new value in the players list. And then when I actually log out on disconnect, it will remove my ship. So that if I close the browser or something like that, my ship will disappear, and other people won't see it. And so as I'm going through this game, I'm kind of going through a big loop that's updating the UI and things like that. But as my ship is moving, I'm going to set the location of my ship in Firebase. And then when I set that, all of the other players are going to listen to that and then actually update their UIs to show that my ship is moving around. So here, I'll have actually a little bit of logic above this that like moves my ship around and changes the acceleration and things like that and deals with me pressing keys and stuff like that. But then afterwards, once I've calculated the new values, I'll just set those to the Firebase, and that'll get synced in real time to the other clients. And this is a little bit small, but it's kind of the same thing. This is the other end of it. So when I want to see other people who have joined the game, this actually is a child added listener. So when somebody joins the game, I'm going to add a new ship for that person to my UI. So here I'm getting, or I've created a child added listener, and then I get a snapshot of the data that has been added. And then that snapshot object, I'm going to use that to update the objects within my my browser or within my UI, so that I can see other players that have been added to the game. And so after they've been added, I want to be able to actually show the movement of those particular players as they move around. And so I'll have a child changed object or a child changed listener, which I also will create that does pretty much the same thing as adding them, but just updates the UI that already exists. And then finally, when those users disconnect or when they log out, I'll check the child removed list or check the for the when the child is removed, and then actually remove them from my UI. And next, the game would not be fun without bullets. So here, this is actually how we would handle the firing bullets at each other. So in this case, each user is responsible for creating their own bullets. So like when you hit the space bar or whatever, it'll create a bullet and then push it onto the bullets list, and then that gets synced to the other clients as well, so they can see it and they can react accordingly. So here's the sort of the same thing. You get when a bullet has been added, I'm going to add it to the UI. And then when the bullet is removed, actually after a certain time period, I think it's like a second or two or a certain distance, then it'll actually just remove it. So it's just not flying out there forever. And so when it's removed, you'll just remove it from the UI, and then you're good. And so yeah. Yeah, my mute, it's muted. Yeah. There's this mic, but I don't know like if I can unplug it or not.
Yeah, we don't hear an echo.
I don't know what that would do. Yeah, I turned off my
So it's this one.
yeah, it might be this one.
Yeah, that's probably a better idea.
Does it sound better? I guess.
No more echo?
It's probably this mic. Okay. So I guess I'm gonna have to stay near the podium. All right, guys. Okay, so it's still there. Yeah. What is that? I have no idea what that is. Yeah, mic is muted. Yeah, okay, I'm just going to keep going. So Firebase does a fantastic job of making it easy to set up those type of real-time applications. So let's see. So that's great and all. Like you can, all the players can kind of play each other and that sort of thing. But what happens when you want to add a computer player? What happens when you want to add an AI or something like that? Each of the clients is responsible for adding data and then syncing that and having that synced to the other clients. So then, if you want to have an AI, then somebody has to be able to be like managing that. The server side doesn't really have any logic there. So how do you do that? Well, you can actually create a bot application that runs on a regular machine, and then have that bot basically run your AI scripts for your the computer players. And the bot will actually just interact with your Firebase the exact same way as your Android applications would interact with it. So it's basically you have an AI player that logs into your app and will actually interact with the Firebase and create their own ship and move it around and shoot bullets and things like that. So that's what we're going to demo here. Is everybody still playing the game? What is it like now? Everybody quit? Like, seriously? I thought you guys like were like playing a game and like not listening to me. I was getting kind of afraid. So let's see if I can make this a little bit more interesting. First, I guess I'll just go through and talk about what the bot AI does. So the bot AI that we've created is a Node.js application. And so you basically can write the bot almost exactly the same way as you write the JavaScript in the browser. So here what we have is we have a little timer that kind of runs in a loop and then makes decisions about what to do. So here we have a really kind of dumb bot that's going to like do some random stuff to decide what to do, whether it's going to shoot bullets or turn right or left or turn left or shoot or whatever. Oops. So let's actually let's demo that. You know, that would be cool. So I'm going to log into my instance that I have on Compute Engine. Come on. And I have my MMO Asteroids app here, and I've got my bot. So my bot is basically just a JavaScript application. So I'm just going to, if you actually look at, so if you look at it, it's just a regular JavaScript app, and it runs the same way as it would in the browser. So the code is pretty much exactly the same. You have the Firebase references and things like that. But what I can do is like my node bot.js, and that'll actually start a bot and log it into our game. So if I go back to the game, we should see a bot here. And he's pretty dumb. He's not moving right now. He will start moving though. Oh, geez, Cindy. So that's cool. Like we have one bot, but what if we wanted to have lots of bots? So let me actually. Create a screen session here. And go to the bot. Bot.js. Okay, there's one. So you can just basically start up a process. Like you can actually make the bot be like log in multiple times, or you could just start up a new process for each bot, or a new node process for each bot, which is actually what I'm doing. So if I go back here, I should see at least 3 bots running around here. So this can get pretty crazy pretty fast. So in that way, you can kind of create like really kind of more interactive and engaging kind of games. Hopefully, you'll create a more smart AI than we've created. But basically, the technology is there for you to create these kind of more interactive games. So let's go back to the. So in conclusion, we all know that mobile is important, and that these type of apps, these type of real-time apps and games are important, and like we want to be able to do this. Like it's pretty important to create these kind of engaging engaging kind of games and games that can act in real time and you can really you can do with other people. And so making that easier is something that we really think is that is important, and so that people can focus on making the game more engaging, making their bot smarter, because we didn't really have a whole lot of time to do that. But actually, not having to worry about the database saves you a lot of time that way. So basically, if you try to build the AI or build the backend, run it in MongoDB or MySQL, and then store all of your files on a machine, and then try to serve those over a CDN and all of that stuff, it would actually be really pretty complex, and you would have a lot of things that you would need to set up. But Firebase kind of handles that all for you. So you can kind of replace all of that stuff with Firebase and then not really worry about it. So you can kind of focus on the application that you want to build. And then on top of that, you can make it even more engaging by kind of using other or integrating with other clouds. So in my case, I used a Compute Engine VM to run my bots, but you can use things like App Engine or other types of backends in order to power those kind of aspects or those type of more engaging bots and things like that. So that's it. So Firebase is actually really easy to start. There's a free tier that you can get started using. If you go to firebase.com, there's also a lot of really cool tutorials and sample apps there that you can play with. So I really encourage you to go check it out. There's a tutorial, a getting started kind of tutorial that'll take maybe 15 minutes to get through, and so I think that's really well worth the time spent. So I encourage you to go check it out. Thanks a lot. So if you have any questions, anybody? Yeah.
I think one thing that's sometimes a bit concerning for developers on Google products is more than one environment that does a similar thing. I'm just wondering if you can speak about this, but where there's a lot of talk about Firebase at Google I.O. this year, where Google sees Firebase in relation to sort of suite of SQL and NoSQL already in the compute system.
Okay, so in terms of you're basically saying we have a lot of backends or databases. Which one or where does Firebase fit in that?
Yeah, exactly.
Okay, so we see Firebase as mostly as a backend for mobile applications, or to enable mostly mobile applications and these kind of real-time applications. It's actually starting to be moved towards actually helping to, or mainly supporting things like most mobile applications. But we also see it as being a place where you can actually use or a service that you can use to enable real-time applications. So things like Cloud SQL or the other databases aren't going to give you those kind of real-time components. So when you want to do something that's like a real-time chat app or things like that, you can actually use Firebase's real-time components to enable that, as well as use Cloud SQL or something like that to store your real user data or your or other types of data.
Thank you.
Yeah. Any other questions? Yeah, you in the back. What's that? Yeah. Okay. So I'll repeat the question. The question was when somebody wants to try to decide between Firebase and Parse, why would they choose Firebase? So I think the main part of that is the real-time aspect of Firebase. That I think is really powerful. I think that also the Parse and Firebase both have kind of UI components. I think that you can install or you can add to mobile applications now. So that's not really all that different. But I think that the real-time aspects of when you change a particular value in the Firebase, that can get synced to another client's device. And I think that's really the differentiator between the two, or the biggest differentiator. Yeah.
You spin up Firebase on your own network, you don't have an outside connection.
So yeah, Firebase is a hosted service. So you can't like download it and install it on your own machines and stuff. You would have to like be able to connect to it from the internet or through a network that way.
So the network goes down, you're kind of out of luck.
Actually, that's an important point that I didn't really talk about too much, which is that Firebase actually supports offline. So Firebase keeps a kind of a local cache of certain parts of the database. It doesn't keep a local cache of the entire database, just the parts that you really need to keep. But you can actually run your app in offline mode, which will allow it to store the data locally, and then when it comes back online, then it will sync up the data. So it's basically as if you're adding a little bit of latency to the application, but in reality, like you're storing it locally and then kind of syncing up later. So that works really well for like things like when you're on a mobile phone and like you lose connection for like a minute or something, and then it comes back. So your application can continue to run. It doesn't have to deal with the connections. Like Firebase just kind of handles that all for you. Yep.
How do you handle conflicts after that?
So that's another thing that's kind of you do have to do a little bit of trickery in order to like handle conflicts for things where multiple clients update the same data. But you can do transactions in Firebase so that you can do basically atomic updates. So if you go away, then you're basically your transactional timeout, and you won't be able to update that key. But otherwise, you can. For most apps, what you want to do is like actually have each client like writing to different parts of the data. So like in the app that I was talking about, each person was responsible for their own ship and their own ship moving around and things like that. So my app wouldn't update the same keys, or in general wouldn't update the same keys as the other apps. They would basically just be. I was just basically updating my UI when somebody else changed a particular key. I wasn't actually changing the same keys that they were changing. So a lot of apps can kind of get around that way. Yeah.
So my question is, if you're playing a long duration game like chess, where you're going to play over a long period of time, over a couple of weeks or maybe a month,
okay.
Is Firebase going to so real time? Is Firebase going to persist?
So the database is persistent. So like when you connect to it again, you can get the state of the database, and it will you'll be able to view it and things like that. So it's not going to go away if like everybody disconnects or something like that. It's not like ephemeral. It's actually persistent, so it'll stay there. It's like a regular database that way. Yep. Yeah, we also have a fire test demo, which is persistent. But any other questions? All right, great, thanks.
Thank you, Ian. So it's time for raffle tickets. We have small prizes now, but the big prize will be at the end. Actually, let me say what it is. Actually, there are actually two wireless chargers. This one is a power box, and this one is another one, a cheap charger. So two of them. So for this one.
So we have 653034. 653034.
Where is she? Oh, okay. So we have to draw another one. Mix it up.
Okay. 653057.
Oh.
Like charging it right now.
Let's see. Do you mind? Okay, great. Thanks.
It goes down here, but it's below the floor.
Just need that.
So we're here, but the floor though, I cannot see.
Yeah. It didn't happen with them. It's so weird. That's why I'm kind of trying to stick with one because sometimes I don't want to kind of.
Can you hear me, Jason? Yes? Okay, great. No echoing, right? Everybody? No echo? Good. So we'll give people a couple of minutes since they're like asking questions. And it's 10:30 right now. At 10:35. Okay. And then we'll go until 11.
As long as you make sure to share your screen so I can see your slides in the hang.
Oh, yes. Okay, let me share that right now.
I wonder, so it had to be something.
Maybe he logged in twice.
I wouldn't do it. I was smart.
I know this.
I can use the same computer.
That would be great.
Yeah, that makes sense.
Okay. Yeah, I have your slides and everything. I have Android t-shirts, but they're too dramatic, so I didn't. It's like a super Android. Yeah.
Yeah, that's my favorite one.
I have the Android music one. I really wanted to wear it. Okay, where is the share button go?
That's why I share with you so that you can make sure any impact instead of having you email it. That's why.
transparent cards, right? Like that type of thing. I think that looks nice. This sort of like here, like the way that this looks. I think that looks good. I think we'll figure that out.
There are some platforms supposedly
They have this thing here already. And then, would you like to use this or this or which one? I think sometimes it can be easier because you can actually control this. And then you can
I've got some things out Play Store. You can search for the title of this actually number 50. So I'm going to add that's my observation.
Okay, let's get started. We have Asmik from Disney. She's going to share with us about material design and how to implement material design with the design support library Marshmallow.
Hi guys, my name is Hasmi Kantayan and I'm here to talk to you about the Android Design Support Library. Are you guys excited for this?
Yes.
Yes, because this is something that really excites me. So I was asked to talk about any other subject, I would have done it, but I wouldn't have been as passionate as I am if I was talking about this. So first, what is it, in case you haven't heard about it? So this is a library that was introduced to help developers implement material design concepts. And it was introduced quite recently in Google I/O 2015, and it is backwards compatible. It's a really awesome tool to help developers unify functionality. So our material design apps all act the same, and it's easy to do. A lot of the libraries that were introduced here, you'll notice, are for very common tasks that we've all had to do before, the hard way or the custom way. This is one of those things, though, that's a lot easier to show than tell about. So I think we're going to go ahead and do that. But before, who am I? Again, my name is Hasmi Kantayan. I've been a software engineer for pretty much all of my career. And I got into Android about 3 years ago. I know what you're thinking. You know, Android has been out for 8 years. I think we had a birthday last week or something, the 8th year. It's like 3 years, that's not a lot. But I like to think of it like 3 Android years, which is like equivalent to 21 normal years, like dog years, you know? And that's because technology changes so fast. It almost doesn't help you if you knew it before. And that's what I really love about this, and I'm really excited for changes like this. So I'm currently employed with Walt Disney Company. Yes, in Seattle. Yes, we do have an office. It's a huge mobile team. If you're interested in that, come and talk to me after. And like I said before, I'm really passionate about this subject. Okay, so let's get started. Okay, not quite yet. I lied. We cannot talk about Android Design Support Library without talking about material design first. So in case you guys are not too familiar with it, let's go over what that is really quickly. So material design has a definition, and these are from the Google documentation. It's a single underlying system that allows for unified experience across platforms and device sizes. Yeah, that definition needs a definition of its own, I think. That doesn't make sense to me. So material design is a design guideline and language developed by Google, and this was introduced in Google I/O 2014, so a year before this library. And again, it is backward compatible, so you can use it for apps that are older than, I think those 5.0, well, older than 5.0. And I think the way that we need to think about material design is that it is a language, so we talk about certain design concepts the same. So we know what it means when one developer talks about cards, one developer talks about colors. So material design is a language, and the material part of material design is a metaphor, because all the views look like they were made out of something real. Or, as again, this is straight from the documentation, it looks like paper and ink. So what this means is all of our apps, all of the views in our apps have a certain physics they follow. So this isn't a one-to-one correlation to the real world physics, but UI elements can't go through each other. They have a little bit of a 1 pixel dimension to them at a minimum. So this is something that we keep in mind whenever we talk about material design. Items that you see on your phone are real. They also respond in a way that's very natural for other objects. Okay, you can't really zoom in on paper if you click on it, but you can bring something closer and far away. So think about it that way. There's also a lot about motion in material design. And motion is a really big subject. And I have to say, I think it's often misrepresented in applications. Motion is not a decoration. You don't use motion because you want some llamas running across the screen on top of your app. Motion should be meaningful. I guess if you had a llama app, that would be useful, but other than that, no. So motion should be in response to a user. It should be used to get attention and show where new content is. We'll go over this a little bit more later on. Another principle of material design is bold colors. So why do we care about material design and therefore the design support library? Think about what makes an app intuitive and easy to use. Also, what makes it really, really frustrating to use. I'm sure we've all had apps where we're like, what is this? And you just uninstall it immediately 5 minutes in. Material design and design in general helps bring better user experiences to the users because it unifies how we do things. So every time you launch an app, you don't have to figure out how to do something, like add something new. You start recognizing that a plus button means new, that the little lines means a menu usually. I think with good implementation of design, specifically material design when we're talking Android, what it does is you no longer need those tutorial screens you see on an application. That's like my pet peeve, you know? You launch an application, there's like 10 pages of instructions about how to use the app. It's like, no, that's not what an app is supposed to be. I should be able to discover all simple functions easily and more complex within a click or two or 5 minutes of exploring the app. Design helps bring our apps to that state. I also want to make a note here that there is an interesting balance we have to keep between corporate branding and design. There's always this, sometimes we butt heads with that, you know? When your app insists that all buttons have to be triangle and you're going to say, but that's not a material design concept, triangle buttons. But how you deal with that is, I can't define these in the slides. It's something that you have to talk with your company, with your designers, with your project managers, and figure out what works best to keep the integrity of your brand, but at the same time make an app that's intuitive. I think we tend to go a little bit more towards the brand than we do the platform. And that's something that we as developers and designers can help change in the future. I think I talked about most of these points, but I just want to quickly go over them. It helps make apps that are intuitive, requires less instructions. We start implementing platform-specific patterns for the good user experience. So those are all the good things. But I also want to caution to not take it too far. Material design is not the holy grail of everything. It's not like if your app is not material design, it's not a good app. There's a lot of good UIs that are not material design. And while I do encourage you guys to implement it in any new apps that you make, doesn't mean that you should drop developing features for the user just to go back and change all your app to material design. We also have to keep in mind that any design is something that evolves over time. This material design wasn't around before 2014. I'm pretty sure it's not going to be around in the next few years. That's because design evolves, changes. We should keep an open mind to new design concepts that come in, and we should be always willing to change to meet the times. Okay, that was material design. By now, you've probably forgotten about what the design support library was. Again, the design support library helps to implement material design. So I'm going to go over some of the cool new features about it, in it, not about it. We won't be able to go through all of them, but I think we'll hit a lot of the big ones. And actually, you have a material design code lab later on that you'll get to implement a lot of these. So if I'm going a little bit too fast when I show the code, don't worry about it. I can either go over it with you afterwards or in the code lab. And this is just to give you an idea about how it's done. First, it was introduced with Android M, and it is backwards compatible, and it's really, really, really easy to use. You can import it with Gradle dependency. All you have to do is go and add in your build.gradle file one line of code. I think 23.0.1 is the latest version, and a lot of examples on the web were using 22, which is the previous version. Okay, so let's start talking. The first feature that I'm really, really excited about, and it's like one of the most simple features, is this text input layout. What the text input layout does is it wraps around an edit text and provides some enhancements, like an always visible hint. Now you're probably thinking, wait, edit text already have always visible hints. Well, what about when you click on the field and make it active? Nope, we didn't have that then. There's also a convenient way of showing errors. The reason I'm most excited about this is because I don't think I've ever worked on an app that doesn't have an edit field of some sort or another that the user has to fill in. And every time the error handling, how we do it, is a custom job, and it looks different from app to app. And I really, really hate that. Because again, we try to keep things the same so the user gets the same user experiences, knows what's going on. So what does it look like? Like this. The first field, the first name is right now what the user has selected. So you can see that the hint has animated and has gone up above the line. So the user can continue typing in and see what field they're supposed to type in. Before the user clicks on it, it looks like exactly like the last name field with a hint in gray in the center. I mean, it's so simple, but it's so cool at the same time. I think this is a good one to start with. How do we do it? It is literally a wrapper for the text, edit text. So here I have two edit texts. We have one that has first name and last name as a hint. Notice that I'm putting in the hints like always, you just put in the hint field. So the text input layout is wraps around it, and it has its own unique ID. This is really it. I mean, this is all we had to do. But we can take it a step further because I mentioned you can also do error handling with this. Here's an example of what the error looks like. It's at the very bottom, so you can have technically a hint and an error at the same time. And in this case, we have a last name is required field, error. So how do we do it? So this is not XML site, it's on your code. You go and you find your text input layout field. So this isn't the edit field, but the wrapper around it. What to do? You enable errors by setting set error enable to true. And then here you have your logic. Maybe you're doing this when the user clicks submit, right? It doesn't make sense where you just automatically put an error, but just for shortness of the code, I made it like this. Then all you do is you set an error on it, and there it is. Okay. Are you guys getting excited like I am about this library? It's so simple, guys. Let's talk about another one of the really cool tools, the floating action button, or the FAB. I have to admit, I'm probably going to call it a fab button a few times in this talk because I don't know why it just sounds better as a fab button, but fab already has the word button in it. But I had to go back in my slides and actually edit button from a lot of them because I was like, no, it's not a fab button. Okay. So this is the little round icon you see here. Right now it's implemented with a cross for adding, and it showcases promoted actions for the user to perform. It's always represented by a circle, and it floats above the rest of the UI. We'll talk about that part a little bit later. And it comes in two sizes, default and mini. So how do we implement this? Very simple. Here's the floating action button, and we just implemented by importing the Android.support design widget, and there it is. We can set a color to it. Actually, if you don't set a color, the default is not that pink. It's like a teal color. And notice that I'm using a coordinator layout to put it in. Some of you guys might not be familiar with it. I'm just pointing it out, and we're going to ignore it for right now because we are going to talk about this later. But it's just in the layout. Think of it as a frame layout. The layout anchor tags are related to the coordinator layout, so again, this is something we can kind of ignore for right now. But the button itself is that simple to do. There's other fields you can set. Like I mentioned, you can set the size of the button to regular or mini. You can set a background color using the background tint. And you can set a ripple color, which is the effect when you press it. So the user has some interaction that they actually press on the button. Let's talk about some do's and don'ts. I think with the fab button, it's such a simple concept, but there's a lot of things that we do not want to do with that. One, do use a circle for all of that. It just, again, I think I talked about it. You know, if you use icons, triangles, it won't tell the user that this is a fab button if you go and you change the shape. Promote only major actions to the user. You don't want to put something that's really minor, like maybe 1 in 100 users do once in a while, this big center, you know, or in the corner. I also want to mention, it doesn't have to be in the, I think it's always on the lower right corner. It doesn't have to be there. Google design documents say that it can be anywhere else on the screen if you want. Maybe you want it in the upper right. Do animate the fab on and off, especially when changing the action performed by the fab. Why is this? We talked about how in material design, animations need to convey some kind of meaning. Let's say that my plus button needs to change to an edit button after a user does something. If I just change it without animation, there's a big chance that the user might notice this. Animation in this case is a way of drawing attention to the fact, hey, this changed. This is what good animation is about. You kind of subtly tell the users without, you know, a tutorial or like, look, this button changed. It's a very subtle thing that we do. Don't give the fab extra dimensions. It floats above the rest of the views, and it needs to stay there. You don't want to make it like far, far above, you know, or any layers between it. Don't use the fab for destructive or minor actions. This is because, I mean, it is pretty centrally located. It's pretty big. We don't want users to accidentally do things that are destructive and they can't undo, right? And don't lose the Z position of the fab via animation. So this is very interesting, but we really want to maintain the fact that the fab floats above the rest of the content. So let me give you an example of when we don't want to do that. Let's say you have some tabs and you want to swipe to change them, and each one of the tabs has a different fab action on it, right? So you know that you have to animate to change the button. So what you do is with a swipe, you animate the fab off the screen, and you bring in the new one to the tab. We don't want that, because that gives the impression that the fab actually lives on the content that's below it. So in that kind of situation, what you can do instead is as you animate the screens to the left or the right, the fab can go down and then come back up. It maintains its Z position. It looks like, oh, this is a different content and it just changed. So the last thing, again, these do's and don'ts are from the design documentation. It says don't use multiple fabs per screen. I crossed that out because I've seen this done a lot. And this isn't a Google example, but I think I was just thinking about it, like Hangouts kind of has something like that. It's not a fab button, but it's like little icons. I don't know. I see this pattern being broken a lot. So I don't know what to recommend to you, but remember what we talked about. Design is something that changes all the time. Maybe this is it. Maybe there's certain uses that this is a good idea for. So that's up to you to decide. Okay. I also want to talk about this kind of a side topic, but there are a lot of icons available. I don't know, when I'm making my own apps, like icons are always a big deal because I know a little bit of Photoshop, but not enough. This Google provides with us a lot of icons. You can choose to have them in black or white, and you can just download them to different sizes for your app. And actually, you can also download it for iOS, so you get the 1x, 2x, 3x. So if you want to share with your iOS buddies, this is a good tool. And you can download it as SVG or a PNG, or there's also a font, which is great because then the icons are vectors, and they take up very little room, and you can resize them to whatever size you want. So this is a good resource to use with things like fab buttons. Oh, I did it. Oh, I went through almost the whole thing without calling it fab button, and then at the end, okay, the fab. So this is just a good resource for you to remember. Is there a question?
So for the plus button and the icon, is it something that provided by Google?
No, you do have to do your own, and that's why I mentioned this resource, because you can find that icon here, and it'll look really good. We're going to take a break. No, you don't get to go. Please remain seated. No one even moved. But that was part of my script, and I'm going to say it. Let's look at some examples of material design. I think, again, it's one of those things that's easier to show than tell about. Here we have Google Music and Swarm. These are both very material designs. The orange, the fact they're both orange is a coincidence. You do not need orange to do material design. But the bold colors is one of the concepts, right? So think about it. Orange is a very bold color. Two more. Simple weather. I actually found out about simple weather when I was doing research about what are some material design apps, and I love it. Like, I want this now. I'm like, I'm not going to install this. And we have Google Calendar on the right. Again, cards. It's bold colors. Google Keep. I was actually going to take a screenshot of my own Google Keep because I use it a lot, but I had like the weirdest notes, like dog, question, 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 and then I had a shopping list that just said like yogurt. And that's it. I was like, they'll probably think I'm really, really weird if I put that. So this isn't mine, but I do love Google Keep. Google Photos. Yes, these are my photos. Apparently, Google Photo that I did a vacation at Carnation where I live and Seattle where I work, but hey, it's still a cool app. Let's talk about this. This is Skype. What do you guys think? Do you think this is material design?
Got some of it.
As good as you're gonna get is Skype. I agree. Actually, I totally agree. I was like, this is material design-ish, which is good enough sometimes. It's got the fab-like button. It's got bold color. Yeah. Yes? No? Anything else? Okay, let's do one more. Nest. I love Nest, by the way. What do you think? Is this material design? Yeah, I don't think so either. It's really cool UI. Like the rain animates in the background. It was raining when I took this. No big surprise. We all live here, and things like that. And it's got cool colors. But I don't think this is material design at all. This is my example of an app doesn't have to be material design to be good UI, right? Tumblr. This is where I get my cat videos from. What do you think? Yes. It does have a fab button. It does have cards. Yeah. I think it does pretty good. Actually, Tumblr won an award from Google about their animations, which I can't display in a picture, but they have really cool and subtle animations that they use, like when you click on the button. Uber. What do you think? Oh yeah, I live in the middle of the woods. There was no Ubers available. I was like, well, this is weird. Okay. Well, it seems not a lot of bold colors. Probably not that material designing to me. Maybe you can make an argument a little bit, but I think these are useful, right? To look at apps with that mindset and see also what components they use. Actually, I've taken a screenshot of like Coin. Have you guys heard about Coin? Yeah, Coin is an app. It's a credit card that takes the numbers from your credit cards, and you can switch which credit card you want, and then people just swipe that and whatever. Anyway, it's like, so you tie your credit cards to this actual physical card. And I was like, yeah, I have to show them this app. And then I was like, wait, this has my credit card information on it. I was like, last minute delete the slide. If you want to see more, I think I mentioned Tumblr won an award for the animations. Here's some links about the Google Design Showcase and the winners. And actually, I have to say, like, at the very end of this video, there's like this one screen where a bunch of apps come appear on the screen and they fly away. And I worked on one of those apps. Okay, that was really cool. I mean, we didn't win an award or anything, but it's cool. Still cool to see something you worked on there. Break time over? Let's talk about the snack bar. I love the snack bar because it has a really cool name. And it replaces toast, and I think I like snacks better than toast. But okay. So snack bar is like a supercharged toast. I said charged, not charred. Supercharged toast. Okay. It appears at the bottom of the screen, and it can be dismissed by swiping if a coordinator layout is used as its parent. It's this mysterious coordinator layout again. We'll talk about it later. And you can add an action callback. So here in this image you see it says archived, and there's an undo. It's really, really simple, but very useful. It has some advantages over toast, like the callback, and also, you'll see. Let's look at it here. Here is this coordinator layout. This is just a parent. I did define it in XML, but that's all pretty much I did. Then in code, like a toast, you pass in the parent view, your message, and how long you want it to appear. Very similar to a toast. Then to show it, you do snackbar.show. You can also do the callback. This is how you implement it. Same, you do the make line. It's very similar. But you also can now do a set action. Set action, and you label. You mention what you want the label to be, and you implement an on-view click listener. View on-click listener. In this case, on click, we just want to show another snack bar that says something else. So then you can also do set action text color red, so or green or blue or whatever you want, just to customize it a little bit. And then you just show it like before. And this time, you see something like this. So this was our first snack bar with Hello World again, and there's a buy button. You click on it, and it says goodbye. Actually, I think I took a screenshot as like the snack bar was going down, so you can say that it is animated really prettily on and off the screen. It's not like a shorter version of the snack bar. I was like, yeah. I still haven't learned how to do like screenshots on the Mac. Like everything else I'm good with it, but it's just like, I don't know. It's like 8 things you have to press. Okay, snack bars, do's and don'ts. Have short, concrete messages, like message sent, please try again. Not like, we're sorry, we don't know what's going on, please try again later. That's not good for anybody, that's not good for you, that's not good for your users. Short. Remember that the user is not blocked from other actions while the snack bar is up. That's actually very important. This is a design choice because we never want to make the user feel trapped in our application. Don't stack multiple snack bars. These are not meant to be a way of communicating with the user. This is not like instant messenger where you have snack bars appearing talking to them. Don't block the floating action button. We'll actually talk about this more, about how we go about doing that. Don't add multiple actions to the snack bar. So either have no action or have one action at a maximum. This is one of those situations like just because you can doesn't mean you should. This is definitely one of those situations. And last, don't dismiss the snack bar or have a callback that dismisses the snack bar. You can set how long the snack bar lasts via the length. And there's some cool things that happen with a snack bar. For example, if the user loses focus and comes back, the snack bar will still stay for the same amount of time to verify that the user has seen it already. So there's no really good reason to implement your own dismissal for the snack bar. Okay. Let's talk about the tab layout. I know we already have tabs with the action bar, but if you notice, all the methods related with navigation to the action bars are now deprecated. This version of tabs really is easier to use and really awesome. So what do tabs do? Tabs provide group content, and it provides the user with information about, hey, the content that we're looking at right now is related to this subject. Remember about that too, right? That's the difference between that and a menu, for example, because the user does not get that visual hint about what the content is. How do we do it? Well, we have the app bar and the toolbar, and in it, we just define the tab layout. You can set the tab text color, you can set this tab selected color, you can customize it like that. Then, in our code, we find the tab layout view, and we just add new tabs. And we can set the text right there. Here we go, item 1, item 2, item 3. Notice I've set the selected color to be this teal color. Okay, so that was the tabs. But if you click on these tabs, you notice they do absolutely nothing, because it's not enough to have tabs. Think about tabs as buttons. They're not good, you know, you're just like, oh, this is great, tabs. The content doesn't change. So how do we do that? Let me show you. So what I've done is outside of the app bar layout, this is the same code as before, right outside of it, and so it's siblings with this, I've added a view pager. I've also created 3 fragments, completely different fragments with 3 different layouts, layout 1, 2, 3, and fragment 1, 2, 3. So how do we bring this all together? Easy. Same code as before, we create the tabs. We also want to find this view pager, and we want to define a view pager adapter. Let's quickly take a look at the adapter. The view pager adapter extends fragment pager adapter. And in this example, I showed also a title list, but in reality, all you need is the fragment list. You can also store other information, like for example, if you want your tabs to change somehow, this is where you would keep it. For example, in this case, a title. So this is not as vital, but it just showcases how you can pass more information to. The one method to pay attention here is this add fragment one, which takes the fragment and the title and just saves it in the adapter. Let's go back. In the view pager adapter, we add the 3 fragments. We set the titles, which are different than the tab text, right? Because maybe we wanted just any kind of information you want to store there. And then we set the adapter in the view pager. Last but not least, actually when I was writing this example, I forgot this step, and I was like, nothing works. I thought this was easy. But we have to let the tabs know what view pager we want them to be associated with. And it's just a simple one line. Tabs.setup with view pager. There it is. Yes, this is my app. It's not like a broken TV. I noticed my color choices were a little bit off, but hey, I'm going for the bold colors, right? So we have 3 tabs with 3 different fragments, 3 different colors. Pretty easy to do, right? Okay. Remember, tabs are high-level organization tools. And that kind of the same thing. Don't use the tabs in place of carousels for content pagination. Also, be careful when you add a fragment that also has a swipe motion, because tabs naturally you want to swipe. So if you have like a map that's also swiping and you have tabs, it might cause some difficulties for the user. Make sure you don't have multiple rows of tabs. That just looks tacky. I never thought that an app could look tacky, but then I saw some examples of multiple tabs. I was like, yes, this looks like something like, I don't know. Anyway, but do try out the different types of tabs. There's fixed tabs, width tabs, and actually that's what I had because the tabs took up the whole screen. Centerline tabs, rollable tabs, and for all of these, you can also set icons if you choose. One thing to note, scrollable tabs are great when you have a lot of content, but if you can at all avoid them, do so. Because when you have fixed tabs, the user always knows where it is. So it becomes almost muscle memory to click on a tab. If you have scrollable tabs, it might be shifted left and right, and the user has to every time find it. Of course, if you have a lot of tabs, that's not an option, and that's okay. Okay, let's talk about the navigation view. So, I think we've been given guidelines about how the navigation drawer should look for a while now, but it's been mostly up to the user to implement. And we do have the drawer, and you'll see that we do use this, but this really, really makes it simpler, and it's very cool to get really cool looking drawers now with the navigation view. There's a few steps involved, and I'm going to go through them, but I think you'll find that the end product is totally worth it. So this is what it looks like. Notice I have a custom header. I have the menu with icons. Okay, so let's go and show you how we implement this. First, we still use the drawer layout. That hasn't changed. And I've taken again, to make it easier to read the content, but in the content section goes your page, like the rest of the content. I think in my example, if you can see in the background, I have my tabs, right? So just whatever content you wanted for the page. Just remember at the bottom, you also want to add this widget for the navigation view. I also want to make sure that you keep this in mind, that your content has to be in one view. So for example, get a frame layout and put everything in there. This was, again, one of the things I found out the hard way when I was preparing these slides. I'm like, why isn't everything working? Well, you need only two child views for the drawer layout. Okay, when we set the navigation view, we also pass it in two variables, the header layout and the menu. So let's take a look at those next. Here is the header. You can make it anything you want. In my case, I just have a relative layout with an image view and a text view. I think you saw it. It's pretty basic. And here we have the menu. This is not different from any other menu that you've implemented. I have a group here with 3 items, and I have a section here, an item that has its own menu, and you'll see how this is reflected in the final version. Okay, let's put it all together. So find the navigation view, and we need to set navigation item selected listener. So this is what happens when I press on one of the items. In my case, because I didn't have fragments and I didn't want to change anything, all I'm doing is I'm making a snack bar up here. And now you guys know what snack bar is, so I don't have to go over that, right? Then after, we also want to make sure we close the menu. So this is the mDrawer.close drawers. I guess there's certain situations where for in your UI, you might want a menu that's always open. And that's actually a decent design decision to make. But for most applications, I think we close it. Okay, so now what we need is we need to make sure that the menu opens when we click on the left corner icon. And how do we do that? Well, first, we have to set in the action bar what is our home indicator. So here, I'm just setting it in a menu. I'm setting it to the Android figurine. I think it's more common to use like 3 lines, you know, the hamburger menu kind of look. We're also enabling it, so we have a home button. Last but not least, we have to actually make something happen when we click on this home button we just defined. So I'm saying, oh, if it's the home button, open the drawer, and notice that I'm using android.r.id because that's how we defined it earlier. Okay, and this is what happens. If you click on the Android, the menu opens, and when we select something, for example, here star was pressed. Remember when there's pressed, all that happens snack bar in this scenario. Notice that the star is selected. I think I forgot to mention that, but we did specify that. Where is it? Oh, menu item set checked equals true, right? It's true. So that's why it's selected. And that's it. We'll have a really stunning navigation menu here. Trust me, it can be a lot prettier. You can do a lot of cool things like this. You can have in the header the user avatar. You can have them, hey, hi, you know, somebody, welcome back. You can put a lot of content in the header, and it can be very customized. It's a really, really cool feature. Okay, now it's time for the coordinator layout. I've talked a little bit about this earlier, and this is definitely my favorite feature of the new design support library. But I'm also not going to go into it as much as I have the other subject. And the reason for this is really the coordinator layout is a talk of its own. I've watched a bunch of YouTube videos that are like an hour long about this subject. So I'm just going to give you a brief overview and tell you what it is, so you can go and explore it on your own. In the code lab, we do use the coordinator layout for a few things. So what is a coordinator layout? It's a powerful frame layout that helps specify various interactions between the child views. So what this means is, in this layout, when you have different views in it, you can tell them to interact different ways. For example, animate as one of them changes. This is done by the coordinator layout.behavior class. And there's already predefined classes that you can use, like the swipe dismissal behavior or the scrolling view behavior, but you can also make custom behaviors for that. So I took these images from CodePath. I think to appreciate the coordinator layout, you need to see it in action. So it was very important for me to have these. Notice that on the left example, the fab button moves up as the snack bar comes out. Things like that. Remember I mentioned that we don't want to block the fab button. This is how you do it. So it's important to use the coordinator layout for this scenario. Here we have the headers that are expanding, and you see the image, and then you can minimize it to the set min level. Here's another one where as you're scrolling in a list, if you reach the top, you can also scroll the title. And again, you can set an image or anything else you want there. So this all possible with the coordinator layout with very, very little effort. It's not like we couldn't do this before, but it was a lot of custom, right? So how do you do it? Well, we're not going to go into it, but the collapsing toolbar layout is the example we saw before when it expanded and collapsed. And pretty much it's this tag, layout, scroll flag, scroll, exit until collapsed. It's really that simple. A lot of this behavior you can just set in the XML. Here we have a recycler view. Again, we're defining a custom behavior for it, and we're just setting it in the XML. We're using the avar scrolling view behavior. So one other aspect of this is that you can define a behavior and set it to a lot of your different elements. So you can have the same shared behavior, maybe between apps, or even shared between apps, right? Both within the app and with different apps. So let's go back and reset the fab and get a more concrete example of the coordinator layout. Remember when we talked about the fab, I said I'm putting it in the coordinator layout. Why is that? Because remember the moving behavior? When you put it in the coordinator layout, this automatically happens. It automatically pushes the fab button up and down because it knows that this is a behavior that we want. But let's say we wanted to do a custom behavior. Maybe we wanted to move up a little bit more because in the place that it moved up, it blocked something else that was important for our screen. So how would we go about doing that? Like this. Remember, it's all about the coordinator layout.behavior classes. So here we are creating a different fab behavior class that extends the coordinator layout behavior class. And we have two methods that we override. The one is the layout depends on, and the other on dependent view changed. The layout depends on just pretty much says, hey, when should I animate? So in this case, we wanted to animate only when the snack bar layout changes, right? So that's what we're doing. We're returning true when the dependency is an instance of snack bar layout. So you can have it depend on multiple things. So you can return a true for a number of cases. In this example, it's just the snack bar. So what this is saying is, hey, when the snack bar changes, I want to do something too. Next, we define what that something is. And we do this on dependent view changed. You can set any kind of animation that you want here. In this situation, I'm actually doing something that's pretty equivalent to what it's already doing. So maybe it's not an example. But we just set the motion and how we want it to change, and then we return true. That's it. I mean, it seems like magic, but now our fab will do something else. We can make it spin, we can make it dance around the screen. Remember, these are not things that we actually want to do in material design, but we could if we really, really wanted to. So we define custom behaviors, and it's really fun to use. Last but not least, we got to make sure that it uses the custom behavior. So in our XML, we just set the behavior. Okay, come on, are you guys excited? You guys are quiet. I mean, this is really, really cool. I really want to give you an example of this because this is something that happened at work that was such a pain, and I wish we had had the coordinator layout when we first implemented. We had our designers come to us and tell us about this cool concept for the dashboard we wanted in our app. It was going to be your avatar as a circle at the bottom. Then you click on it, and the dashboard opens up behind it and kind of parallaxes into place. And then when you click more, you can drag it up or down. We loved the concept, actually. It was really, really cool. And we were like, you know what? It's going to take a lot of effort to do the custom animation, but we're going to do it. So we had our best developer sit and work on it, and I was actually, okay, it's like, this is going to be so cool. And then we had it. And then our testers got a hold of it. And pretty much for the next 3 weeks, somebody would come into our office and be like, the avatar has detached itself again. And the avatar would be on the left side of the screen, on top of the screen, below it, the dashboard up and down. It was a nightmare. And we had really smart people working on this problem, right? The thing is, it's very, very complicated to do, but it makes the app look so cool that we worked really, really hard to implement this. We finally did it. It no longer detaches. Don't worry about that. But it took so much time and effort that it's almost was like, oh, was it worth it at the end? The coordinator layout, just it would be like a no-brainer to do that because we define the motion when the dashboard changes. We can define the motion when the avatar changes. They can interact. So this is what I'm talking about, that the coordinator layout is hard to speak about in like 5-10 minutes because it has the power to do almost any kind of really cool interaction between different views. Okay, I think that's pretty much it for this talk, but I wanted to make sure that you guys are aware that there's other components that we really didn't talk about that much. The avatar layout has some changes in it that I recommend that you guys take a look. If you have time and you have to look at only one of these things, check out the percent relative layout and the percent frame layout. Now you can set dimensions that are percents. We also briefly touched on the collapsing toolbar layout, but again, it's really, really cool. And there have been some new animation changes in the recycler view too. I think a lot of people are now using the recycler view, and it's really cool to see those changes. Last but not least, we also have new media router and leanback. Leanback is to create easy UIs for TVs, if that's what you're interested in. And the media router is to help stream to via Bluetooth your media. So all these features, and actually more, are in the design support library. I think that it's something that we can talk more about, but I hope that this gave you a good overview of some of the cool things in there. And I'm really excited for you guys to go to the code lab and actually try implementing these, because you'll see it's even simpler to do than it is to show on the screen. All right. Does anybody have any question I can answer? Yes?
I wanted to use the new coordinator layout stuff. I respect you and that. I personally found it the ramp up to getting like all of that working with behaviors quite difficult. The documentation, like to get the exact behaviors for like reaching out and like when you scroll up, if you want the whole header to move up or the toolbar to move up. I guess I don't know what my question is.
Actually, I do understand. That's one thing that I have to say we still have to improve on, and I feel like there's very little documentation about any of these cool features. So that's why when I sat down to make these slides, I literally went and just tried out everything, because you just kind of can't trust the documentation that's out there right now. But I think one of the cool things about just the where we work and the Android is the fact that it's fast moving as a kind of community. And I think as the time passes, we will see lots of great documentation and things like that will be easier. I completely agree with you. Right now, it's hard to even realize how simple some of these things are because we don't have great documentation. I think you'll find that the code lab does a really, really good job of breaking it down into pieces and showing the code. And that's why I think you guys should definitely try it out. Anything else? No? All right. Well, thank you very much, guys.
Thank you, Hasmin. That was a great talk. So we will do raffle tickets real quick. This time, it's a Chromecast. Six 653030. 653030. Nobody? Okay. Great. Okay, the next one, I think you get to choose a t-shirt versus a USB Type-C. So you may or may not need USB Type-C, but you may be needing it desperately. If you got a new Nexus 5X or Nexus 6P, right? Okay. 653003. Great.
one would you choose, the Type-C cable or T-shirt? Do you need that to use? Okay. Let's check the size. Make sure. Okay, great. Thank you. Okay, so let's take a few minute break while we get it set up. Hopefully we'll get rid of that terrible echo.
I figured out the issue. That's the, yeah. Well, I can't fix it yet. There's two sound systems. So these two speakers. All right, testing.
Jason's a producer. He's going to go
Seems like cool. This is a separate sound. Thanks. Yeah, I'll test you. Okay. Perfect.
You do some tests.
Sorry, yeah. Testing. Can you hear me back there? Sounds good? Okay. Cool. Oh, turn it down. All right, is that any better? I turned it down 2 notches. Go up 1. I think that's 1. Any better? Doing okay? All right, cool.
Did it get fixed? What was the problem?
We're good, yeah.
Oh, thank God. It was so annoying. So we'll give people a minute or two.
Yeah,
They'll
totally.
probably take a break, taking a
Sharing, so I think we're good.
Okay, good.
She was sharing just that particular just that particular browser tab, not the whole screen. So I'm seeing her this. Can you go back into the Hangout?
Interesting. Yeah.
And just reshare.
So
the green thing. Nope.
No.
At the top left there.
Okay.
So you're just there. You see this? You see
this thing here? Okay. Screen share.
Yep.
So I'll tell them in about 2 minutes we'll start.
Do it again.
Is that okay?
And then, yeah.
We will start in a few minutes.
The right guy? Okay, cool. Thanks.
Thank you.
I'm just wondering if it's okay, so you should call it. We have a talk, one more talk.
Awesome. I'm already excited about it.
Yeah.
I saw lots of posts on Twitter.
Yes, everyone can get one.
Yeah, I think there's Google Doc.
Okay. Yeah, it's available. After the talk, you guys all can go in the positive. People are so excited. Actually, I got one. Oh, okay. And we don't have to stress out because we got kind of late because Ian pushed a couple minutes and then the microphone. What was the problem with that whole microphone thing?
I have no idea, but they switched to this instead of that.
Oh,
so.
yes. Last time I was
Am I coming through on the speakers? Sounds like they can hear me back there, so hopefully everyone can hear me.
You're coming through from here.
From that.
Yeah.
So should I be talking into both of these things?
You can use this, or do you need to use? I could give you the mic after I introduce you. Okay, that's out here.
To the mic.
I thought mine is bad. People are saying.
Getting there, and then my laptop broke, and then I had to start over. You said it's stickers. Yeah, well, he's just like, now it's not. Now it's empty.
People are asking, oh, you're an developer. Should you always think, how about your Mac? The Apple on your Mac.
Well, sometimes it's cool to have it light up wherever else is in the Apple.
Yeah.
Should we get started?
I'm ready if you are.
Okay.
Yeah.
All right, everybody, let's get started and get back to the talks. So if you guys could please take a seat, we will get started again. Please welcome Andrew Rogers from Facebook. He's going to talk about how the Facebook team migrated their flagship apps to use the runtime permission of Marshmallow.
Thank you, Margaret. Thank you, everybody. I guess compared to some of those last talks, this topic does sound maybe a little less exciting. Permissions, security, privacy. Honestly, this is one of my favorite features in Android recently, and hopefully I can convince you why it's really, really great too during this talk. So a couple of months ago, I think at the beginning of September, we set out at Facebook to update our primary applications, the Facebook and Messenger apps for Android, to use the new runtime permission model that is in Android Marshmallow. And so I'm here to talk a little bit about what we learned from that. We're going to go a bit over the existing Android permissions model, what the new runtime stuff looks like, and just kind of an overview generally. We'll talk about, yes?
Sorry, Robert, for just a second, but it looks like you dropped out of the share. You could
dropped out of the share. Technical difficulties, please stay tuned. Oh, okay. Let's try it again. Are we showing up in the Hangout? Okay, cool. And then I'm going to go through what we did and some tips and ideas on how to migrate an Android application that already exists to use the new model. And then some stuff on best practices, tools, tips and tricks, and that sort of thing. Oh yeah, but before we get started, I need you all to accept this set of permissions. We're not going to do anything with them. It's fine. Just hit accept. So I assume you're all okay with that. Android permissions. So if you're an Android developer, you're probably intimately familiar with this. User goes to more technical difficulty.
Can you share the entire desktop? Can you go full screen?
All right.
Sorry, everybody.
How do I share the entire desktop? Perfect. I admit I don't use Hangouts very often. Sorry. So, pre-Marshmallow, this is the world most people are familiar with. You go to install an application, the user hits the install button, they're confronted with that thing that I just showed you. It's a big long list, there's a lot of stuff there. How many people think this is a really good user experience? Okay, a couple in the back. So I'm going to disagree with you. Okay, it's better than nothing. I heard that that's good. How many people read all of these? Right. Okay. So, like, if you go back in time, this was pretty cool. This was great. So finally, there was a way that applications could request certain capabilities, and users could see what apps were going to do. But it's kind of old. Big applications often have a big list of permissions. Sounds scary. You have to scroll through all of them. It can be very daunting. And there's really no context provided with this. About the best thing I've seen developers do is kind of put some stuff in their release notes and then describing what these permissions are actually going to be used for in the application. You could sort of imply if this application is asking for microphone and the ability to record audio, hey, maybe they're listening in on everything I'm doing all the time. Not that anyone would ever have a rumor like that. But that's, you know, what you're stuck with here. And yes, rumors like that exist. They're not true. So, with Marshmallow, this problem is fixed. I really what Google has done here is awesome. So, basically that problem doesn't exist anymore. The time you go to install an application, you hit install, it installs. The user's not prompted for anything. That's not entirely true. The first time they do it on a Marshmallow device, you're actually going to see a dialog that tells you you don't have to do anything, and you will be asked at runtime. So this is a screenshot of the check-in UI from the main Facebook application. This is after a fresh install on Marshmallow. The app does not have access to your location. We've updated the UI. It populates a list of places that I have previously checked in, so it's still useful. In order to actually grant access to location to the app, I have to go hit that grant location access button. And at that point, we see this nice system dialog asking the user, do you want to allow it or deny it? First time you ask, the user can deny it or allow it. If they deny it and you ask again, they're given a dialog that instead has a checkbox where you could permanently deny to the application should you not want it. So why is this good? Hopefully it's sort of obvious why this is good. It's no longer all or nothing. That's kind of one of the keys here. I don't have to accept that entire long laundry list of permissions. I can selectively accept ones for functionality I actually care about in the application. You can provide a lot more context to users, not just what you could put in your release notes. But now it happens usually in response to a user action in the app, navigating somewhere, clicking a button. In the example I showed, there's a button you explicitly have to hit to grant location access. So users kind of have some idea why you want this permission, what it's going to be used for. And this one is slightly less obvious. Automatic updates of your app that happen from the Play Store can no longer be blocked. This was a situation that maybe some of you have faced. If you add dangerous permissions to your application and you deploy that application, you may see a slow uptake of that new app, whereas in the past, people updated pretty quickly. And that's because users have to accept the new permissions. So they have to, there's like a manual step. Your app won't update in the background. They'll get notified about it, but they still have to go into the Play Store and install the update explicitly. So this is actually a huge win. So if you're familiar with Android permissions, you might be thinking, there's a lot of permissions. This is going to be a nightmare prompting the user for all of this stuff. It's going to be confusing. It's going to be terrible for developers. There's a lot of permissions. Yeah, sorry for the tiny font, but that's what we get. So if you look through this list, there's a lot of permissions there that are security related, privacy related, but there's also a lot of things that are kind of just basic functionality, things you might consider more like capabilities. I don't know many apps that are useful that don't ask for the internet. So a lot of these things here, if you had to prompt for, it would get super tedious, super fast, and nobody would like it. To help out, permissions have been divided into a couple of different groups. There's actually several, but we're going to talk about normal and dangerous permissions. Normal permissions are things like internet access. They allow the app to access outside its sandbox, but they really don't pose any threat to security or to user privacy. They can't touch other applications, that sort of thing. If you ask for a normal permission in your application manifest, it's just granted to you at install time. The user doesn't have to accept it or anything. It's just granted. Dangerous permissions are the ones that are more interesting. That's what we're going to focus on here. So this is when apps are going to access private data of the user, data in other applications, things that truly could be an invasion of the user's privacy or a security threat. The other types of permissions are like signature and system or signature. Those are pre-existing. We don't really need to talk about that stuff. To make this simpler yet, Google has divided the dangerous permissions into 8 groups. This could change in the future. There could be more groups. But that is it. You have camera, contacts, location, microphone, phone, SMS, storage. These are all pretty easy to explain and understand for typical users, I think. And the interesting thing about permissions groups is that they're granted by the entire group. So if your application both reads and writes contacts, for example, both of those permissions, read and write, are in the contacts group. So when you prompt the first time for read, the user is simply going to be asked, hey, can this app have access to your contacts? That implies both read and write. So they allow that. The next time your app tries to ask for write access to contacts, it's going to be automatically granted without prompting the user. So really what you can see here is we only have 8 possible prompts we're going to show the user. That's a much easier problem to deal with. It's not a terrible UX thing. One thing that's worth noting is that this is kind of reminiscent of another popular mobile operating system. I don't know if other people have seen that. I don't know if anyone noticed that. But. So the new permission model. The behavior is opt-in. Pre-Marshmallow, if you install an app that supports the new model on a down-level OS, pre-Marshmallow, it behaves the same way as it used to. You could have incorporated the new runtime model. There's no like support library for that or anything. This is system support. So if you install a pre-Marshmallow device, you still get the old behavior. So we want everybody to update to Marshmallow as soon as possible, but probably won't happen that fast. To enable it, you have to update your target SDK in your manifest to Marshmallow, which is 23. If you are still targeting 22 or lower, users are going to be given a full list of permissions at install time, and you won't get the runtime model. Permissions are preserved on OS and app upgrades. So this is kind of 2 points, really. If you have a Lollipop version of the OS, you upgrade to Marshmallow, all those apps that were pre-installed. User already accepted those permissions a long time ago. Those remain. They don't have to be prompted or anything. If you have a version of the app that was targeting version 22 or lower, you upgrade it to a new one where you've implemented the new model. Those permissions that were previously granted by the user at install time are basically grandfathered in. So it pretty much behaves the way you would want it to behave, but I've heard a lot of questions around this. This is another interesting point, and also really great for users, that users can go back and revoke permissions for applications. This, even if they previously allowed it via one of those dialogues, they can go back here and they can disallow it. Similarly, if they had disallowed it before, they can come in here and allow it. If you are, so this is available for users even on your old apps. So if you didn't update your app to use the new model, they can still control the permissions. Even though they accepted the full listed install time, they can go back and disable these things after the fact, which is interesting and sort of surprising. The good thing is that for apps that aren't using the new model, they basically get mock results for the APIs that are permission sensitive. So as an app developer, you shouldn't worry too much about this until you're targeting API 23. I think it's also worth noting that when you try to disable a permission here on an old app, it kind of warns the user that it might start behaving strangely. So, oh yeah, this is another good point. Somebody goes in and changes this while your app is running. It terminates processes associated with your app, so you don't have to worry about race conditions, time of check versus time of use. So if you sample a permission at runtime, you see you have access to it, you know you have access to it for the duration of that process. Don't persist those results anywhere because it may no longer be true. Don't put them in shared preferences. Might not be true after the app restarts. And a final thing that's worth noting in this overview, this is one of the big motivating factors why we started migrating our applications early prior to the Marshmallow release, is that applications installed by the OEM or carrier on a Marshmallow device that they're shipping, they have to target API 23, which means they have to opt into this new permissions model. And this is another really great thing for users. Previously, if you bought a phone from a carrier, it probably had a bunch of pre-installed apps on it. Does anybody not have that be true? I mean, if you bought a Google Nexus device, you're okay, but if you bought a phone from a carrier, it's probably got a bunch of stuff on there. You never opted into the permissions that that app requested. You didn't install it. It was pre-installed. This here enforces that you do opt in, which is a great thing. It's a kind of a great policy move, and it's really good for users. So that is why we decided to update our apps soon, because there are several OEMs that pre-install Facebook and Messenger. So now I'm going to go into migrating applications. We have some code samples and a bit about the process that we went through migrating our apps. So this is the thing to really kind of take home. Calling a protected API or accessing a protected resource via URI can result in a security exception. This has always been true. I'm sure many of you developing applications out there have seen this before because you forgot to put a permission in your manifest. But as long as you put it in your manifest, this did not happen. There were some things out there. There's some custom ROMs where you can turn permissions on and off, and you can kind of cause this stuff to happen. But in general, you didn't see this in the past. Now you will see this. So how do you avoid it? Well, you can just add runtime checks to make sure you have the permission before calling an API. That's pretty obvious, I guess. In this example, we're calling into the telephony manager, get the user's phone number. That requires access to the user's phone. There's a permission group for that. Right here, we are checking, do we have access to read phone state permission? If we don't, we just return. So the code here doesn't prompt the user, doesn't ask them for permission. This particular example is inspired by a real code change that I made in the Facebook app when getting this to work. So when you're logging into the Facebook app, we attempt to pre-populate your username with the phone number on the device. So we ask the device for the phone number, pre-populate the user. Makes it a little bit quicker to log in. In this case, popping up a permissions request to do that didn't seem like the best user experience. So we simply gated the call to unblock it. And on a Marshmallow device, right now, you don't get your login pre-populated with the phone number. We might consider changing it in the future if there is a good way to do it with a good user experience. But right now, this seemed like the best way to get things unblocked. You don't always want to do that, because then your app might not be particularly useful in a lot of cases. So you want to be able to trigger prompts. So in the code sample here, we're doing a few things. We're using the activity compat library because we're calling a new API, or two new APIs that didn't previously exist. Using activity compat allows you to add these checks and not have to put version checks in the code. So we're calling should show request permission rationale, very wordy method name. But what that really means is, have I already asked the user for this permission and did they decline it previously? And so what that's saying is, oh, they already said no once. Maybe I should explain to them why I need it, give them a little more information. So definitely use this API, definitely provide more context if it's returning false. Sorry, if it's returning true. If you're going to then actually request permission, either that thing returns false or you've provided more context, you call the request permissions API in activity compat. In this case, we're asking for the read context permission. You'll notice that the second parameter takes an array of permissions, actually, so you could request multiple at once. And then the next parameter is example request code. The request code is what we've defined above here. 147 doesn't really matter. This is an app-specific code. For all the permissions requests, you would define codes that are unique so that later, when you get the asynchronous response about whether the user approved it or not, it comes back. You can identify it. Was there a question back there?
What's the behavior silo this app onto a
What?
Or some non-Google Play.
So the question is, what happens if you sideload the app onto a non-Google Play based device? It should just work. It won't prompt the users. They will have already accepted all these permissions at install time. If you install sideload and you go through the package manager to install it, you still accepted a list of permissions. If something like the Fire Phone is updated to run Marshmallow, then I assume they will have something similar like this. I won't speculate on whether or not that will happen or how soon it would be. But yeah, so this is generally just backwards compatible. The API in the previous slide, well, I guess here we're using the compat library one, but there was always a way to check permissions whether or not you had them at runtime. You could always do this, you just didn't really have to in practice. So once you prompted the user, that's an asynchronous call. You're going to get a callback on this new activity lifecycle method. Should probably have pointed out that previous slide, all of these calls need to happen in the context of an activity. And prompt for permissions running from background service. That seems kind of like a security vulnerability. You could theoretically prompt over some other application to trick users. So it really has to be tied to an activity so that we know it's that app that's asking that's in the foreground at that point. So to receive the response, you're going to override the onRequest permission result method. And you are going to look for that same request code that you passed on the initial request. It's a big switch statement. You could have a bunch of them, a bunch of different unique codes. And you're going to check to make sure that you got something back and whether or not it was granted or denied. So I said before that you could request multiple permissions in a row. If you requested 3 or 4 or 5 or whatever permissions there, some of them could come back as granted, some of them could come back as not.
So you get one code for the whole area. You have to look at areas.
So you get one code for the whole area, but you have to look at permissions individually. You get one code per request. So if you are requesting 3, you have to look at all 3 in the response. And yeah, this is an example of what it looks like when you prompt for multiple permissions. It's okay. You get a series of 3 prompts. The user gets to see them individually. I generally would say you want to avoid it because it's not a great user experience, but there are cases where it makes a lot of sense. This is an example where I click the camera button in a messenger chat, and the camera button can be used to take video, for which we need camera access and microphone access if you want audio. And it also can be used to just add or send pictures you've already taken. So the third one is accessing photos and media on the device. So the first one we're asking for is camera. Second one, microphone. Third one is local photos. So we kind of let you go through a chooser of all of those things all at once, so we prompt for all three here. I think it makes sense in this case. It's not always something that makes sense. Okay, so where do you add your checks? This, oh, sorry, there's a question there. Yes?
It might be the same one. How do you know that each call requires these? You need these different reasons to be.
So for the current UI, we needed all three of those permissions to show it. The way that the current UI worked, you could go to the camera, which you could do video or just a picture, and we had the library chooser photos at the same time, so we requested all three. Does that answer your question?
How do you know in advance, or let's say that I'm trying to do something, how do I know that I need to check these permissions before I make a call?
How do you know you need to check permission for you? That's actually the hard part. So we're going to go into that a little bit. How do you figure out where you need to add the checks? That's your question, correct?
Yes.
Okay. This is almost pointless to put up here, but obvious calls where you're accessing those big groups of things, or big groups of dangerous permissions that I explained. Location, contacts, SMS, phone. There were only 8 of them, so it's not that many. You're going to know where a bunch of these are used in your app, I hope. There's a lint warning. I will warn you that the lint warning is not complete or wasn't complete the last time I ran it. I didn't check on the very latest SDK. So the lint warning checks or can warn you on APIs where you might not have asked for the permission or where the permission could be denied and you need to add a runtime check. It's driven by metadata that comes out of the Android framework. There's a bunch of annotations there. Not everything was fully annotated the last time I looked. So this can get you a little bit of the ways there. But even like the accessing the phone number example I had before, it's not warning me on that one yet. So I expect this to get better over time. And this one's stupid and painfully obvious, but watch for security exceptions. Honestly, this is how I found most of the places that I had to add checked. You're going to see them in Logcat. Security exception, it's very clear. I have a couple of examples of them right here. In this case, we're saying we don't have, I'm sure you can't actually read this because it's super tiny, but Android permission, send SMS. Particular process does not have permission to do that. Trace back up to the first code, or the first frame in the call stack that is in our application. And I can see, yep, I'm trying to call send SMS. It's calling send text message. That must be a protected API, so I need to add a check there. So obviously you can go in and just add a do I have the permission check there and not do it if you don't have it. In some cases you're going to actually want to prompt. This might not be the right place to prompt. It really depends on the context. Another very tiny example. In this case we're accessing a URI that we don't have access to. So it's not calling an API we don't have access to. It is trying to get at the media, external audio media directory from a content provider, and the process doesn't have access to that. You can see here it is trying to get a ringtone URI. So you have to watch for that as well. And there are places where you're going to use content providers, you're going to use URIs where you also need to add permissions checks. So that's just something to be aware of. I don't think the linter can even find those for you. So maybe it's super smart, but I haven't seen it. So how do you migrate an application? This next set of slides is really the process that we went through trying to migrate the Messenger and Facebook apps. First thing, you need to get your app to build against API 23, the new SDK. Before this, we were building against the API 21 SDK. There were actually some things we had to change just to get it to build. I think the most noteworthy thing, they're not hard things, you just have to find them. Android had this float util, like float math helper with square root and stuff in it. That's gone. It was deprecated, but now it's literally gone. So you have to switch all those to use java.lang.math. It's a pretty painless transition. But I think the harder one is that the Apache HTTP library is now deprecated completely. It's no longer in the framework jar. It's been moved to a separate jar. So if you have references to anything in that, well, you're better off removing them. In my case, we temporarily are just building against the new deprecated jar. So you have to include that in your build. But once you have it building against API 23, locally target version 23, install it on a Marshmallow device, start it up, and watch it fail with Logcat open. So start the app, exercise basic functionality, and watch Logcat for security exceptions. If you look at something like the Facebook application or a Messenger application, basic functionality there should work without any of these dangerous permissions. So you're going to hit things like I mentioned before, trying to read the phone number, pre-populate the login dialog, things like that where people just assume, yep, if we have the permission, this is going to work. You don't need that for the app to function. So literally, this was me at my computer half a day, not quite commenting blocks of code out, but putting checks in, iterating, and starting it up until we really could just get to a Facebook feed that worked. So there was really probably only 2 things that I had to change, 2 or 3 things on the startup path to get the app to launch and function, basically. Not too bad. Anyone can do this if you have Logcat. And then, yeah, I basically said this. Add calls to gate the offending API calls so you don't call them. Wow, that's off the screen. But it says repeat this process until it works. So the thing you need to do to make this actually useful is prompt for permissions. This was a little bit challenging because we have a lot of different features in the Facebook application with a lot of different engineers that maintain them, add them, and are familiar with them. So we had to parallelize this effort, having somebody go work on the check-in screen, people work on photos, other people work on a bunch of other things. So there's a bunch of UX work that has to happen, a bunch of feature work that has to happen. The way we did this, we didn't want to just upgrade our target SDK to 23, because if we shipped that, it would crash for everybody in lots of random places, assuming they're running Marshmallow. So we just built a very simple mock framework that developers could turn on locally. This wouldn't give you, it wouldn't let you really debug where the failures were or where you had APIs that need to be protected, but it let people develop their UI around places that they needed to, like the location UI, check-ins UI, that sort of a thing. So super simple. It looks basically like the Marshmallow framework APIs, except it is doing nothing by default, and it's storing its own results about whether or not the user accepted the permissions. So this helped developers parallelize this quickly, and we didn't have to update our target SDK to 23 while there were like 3 weeks of development happening. So then the developers went and added permission prompts in the locations that we had identified. And that was so easy. So finally, once everyone was done, we thought everything was done, we modified our mock framework to just delegate to the real thing, and we updated the target API to 23, and then we started testing it. So, rolling out the application. We have a QA team, fortunately, that was able to go through all of our features. They were able to watch Logcat output for security exceptions. I feel like I'm saying security exceptions an awful lot. But they tested it all, filed a lot of bugs. We had people go in and add more checks, add more prompts. There's a question in the back.
Yeah, for prompting the user for permission, run into any situations that have a good way to request a permission that would maybe potentially be expensive to use. So, let's say for instance, for security, you want to have to be high MUI, but there's no way that.
Right. So I think that the phone number is an example of that. In the cases like that, so far we've really just disabled that functionality. And we have to think about it a little bit more if it's something we really need to ask the users to do, if we really need to do it. But yeah, I agree. There's some things where it really doesn't make a lot of sense to prompt users for permissions. And in those cases, I think you're better just to disable them if you can.
Let's say about losing functionality, or let's say for Facebook app, you want to say, hey, this stuff is going around you. Let's just start the app, or losing that functionality because
So the question is, do we lose functionality that would be there by default because we're not prompting users right away for permissions? And the answer is, yeah, a little bit. There's some default functionality, probably things around location that it might make sense for an app to do. And for those things we could prompt the users at startup. Right now, we've chosen not to do that. These are things we might change in the future, though. These are good questions. Some things you really need to consider when you're looking at this sort of design in your UI. Right behind you, actually. Question.
So, let's say you have your app as a lot of third-party libraries. How would you handle how your third-party libraries
Okay, yeah. If your app's using a lot of third-party libraries, what do you do? Those third-party libraries, we didn't actually run into that. We're using a lot of internal libraries. I don't have a great answer for what you do with third-party libraries that are trying to ask for permissions. I'm going to say you probably are going to have to just prompt for these things before you call into those libraries that require that access. That's without thinking about that too much. But yeah, that's a good question. How do you know if the library requires a specific permission? Look for security exceptions in Logcat. I know, that's not the best answer, but okay, one more question and then we'll move on.
I don't know if you guys ran into this, but in our app we're using the vision for a couple of different things. So we use geofences, and also doing ads, and so we've got like time and force. And so like, we can use this like permission group to check if the whole group is being allowed or if we can like ask the whole group permission. And then we need to figure out data like that hasn't really been implemented. We're not supposed to use that. Maybe.
Okay, so yeah, so the question is, should I be asking if a permissions group has been granted? You're still supposed to be asking for individual permissions. So if you're looking at coarse and fine-grained location, they're both in the same group, whichever one you prompt for first. If the user says, yes, allow that one, the next time you still have to ask for the fine-grained one later on, but the user's not actually going to get prompted, so it'll just give you that by default. But the general recommendation is to prompt for everything now, like request these permissions. Don't assume that anything's been given to permission. Things might move groups in the future. There might be new groups added in the future. So treat every permission as if it could generate its own unique prompt, even though they don't right now.
I've written in the future that people are going to open the API data to ascertain whether you are allowed, but that's not.
So is Google going to provide basically an API to see if a permission group has been granted? I can't say if they're going or not. I can say the current recommendation is to just go with individual permissions. I suspect there may be some more iteration going on what the groups are, and post-Marshmallow, that stuff might be tweaked a little bit. So just assume each one's independent, but you only have to look at the dangerous ones. So we did a bunch of testing, found a bunch of crashes, fixed them. We shipped to alpha and beta users, watched our crash logs to see, and yeah, we coupled and found a few more security exceptions. I'm glad we have our kind alpha users that were running the Marshmallow preview build, so this wasn't very many people. But we got our we got all of those fixed and finally shipped the thing. It only took about a week and a half to get all those little bugs worked out. There could still be lingering ones, long tail of features that people aren't using, but we think we know. So. Okay, best practices. So we had this mock framework that allowed us to effectively turn it into a custom framework. It gave us the ability to add a second prompt in response to that. Should I give the user more context API? So you basically have our own permissions prompt here. Explains exactly why you need it. This is only after you've denied it the first time, in the first dialog that I showed earlier. Some of the features in our app use this. Many of them don't, but it's basically giving you, hey, here's really why we need this. Here's a real explanation with more details. If you say yeah, then you move on to the real one. So you get 2 prompts in a row. Other considerations to runtime prompts. Prompting at startup, I think this kind of came up in some of the questions. Still runtime prompts, but if your application really, really relies on something, you have a GPS app, you probably need location. So it makes sense to ask the user for it when they start the application. Because without it, your app is potentially just not useful. We did not do this in Facebook or Messenger, which does limit some things. You can't automatically know when you're near somewhere or something like that. But for the UX, it's probably the simplest thing to do. We might consider it in the future doing something a little more user-friendly so that you can get this stuff at startup. Another option, so I honestly haven't tried this. This is suggested in Google's best practices. Use an intent to perform an action. So there's some cases you can open the camera with an intent rather than accessing the camera yourself. You can make a phone call with an intent rather than accessing the phone directly. Those don't need permission since you're really delegating to another application to do it. So if that's an option, don't even add the permit, just use an intent. Okay, as you're continuing to add new features to your application, now that you've already updated it to the new model, you have to always test it on Marshmallow now. So there's one more thing you have to test on. There's emulator images, great, it makes it not too hard, but this is another level of testing that you have to do. Exercise the allowed and the denied code path, make sure they both work. You can do this using ADB shell PM commands. There's some new things added for permissions. If you're not familiar with the shell PM command, there's a lot of good stuff there about looking at packages on the device and what they can do. Some of the useful permissions, you can list that first command there, list permissions -d-g, lists all of the dangerous permissions that the app is aware of, or sorry, that the system is aware of, and groups them by permission group. It's really useful and probably more up to date than the online documentation. So you can use that to figure out, is my permission dangerous? Is it in the same group as another one? Just call that. It's super easy. You can also grant and revoke permissions for a specific package. It's a little bit easier than going into the settings UI. And then you can reset all permissions across the entire device, which could be useful, but also could be annoying if it is your own personal phone. So once the user checked, ask me again, you can't trigger these prompts anymore. That's good. We don't want to annoy users. Like, that's why there's the checkbox there. But what if your app really depends on that functionality? The user wants to do something, and now they can't, and now you can't ask for their permission. What can you do? Well, you can navigate them to the settings for their application and encourage them to go enable it in the permissions setting. You can't navigate them directly to the permissions activity that I showed previously. You can navigate them to their app settings, at which point they can click on permissions, and then they get the permissions little thing with the switches on it. That's the best you can do right now. If you want to launch settings, give users a whole bunch of context first. I'm going to send you to settings. You need to go to permissions and turn this thing on if you want to use my amazing feature. Action application detail settings that takes people really out of the flow of your app. It puts them somewhere else, completely different activity. They have to navigate back. Avoid doing this, but if you absolutely have to, you can. And this one's interesting. Drawing overlays. Who's familiar with system alert window permission? Okay. This isn't commonly used. This is what we use to implement Facebook chat heads functionality. There's other apps like Link Bubble, and this is how you get cool like things over the UI where I can always have chats or I can always have links open. This is not a dangerous permission anymore. It is now, I think, I'm not sure if Google's calling it this, but it's a capability. It's more dangerous than a dangerous permission. That's at least how I interpret this move. So if you need to enable this, you can't prompt users. So in the Heads app, we actually had to implement a special case, go to settings, and you can intent directly to this permit drawing over other apps. The user experience here, I think, is really pretty good. We can't turn it on by default, which I think is probably good. So now if you want to use chat heads, you go to settings, you hit chat heads, it takes you to this menu, and then you can navigate to the settings to enable it. So I think they moved one other permission to this kind of capability, and that was like writing system settings. Probably nobody is using that, although I did notice a few of my apps are, and now I'm suspicious. Yeah, that's drawing overlays. So you also don't check for it like a normal permission. There is a new settings API, can draw overlays, that you need to call to determine if you have this capability. And if you need to launch the intent to get there, it is action manage overlay permission. Specify your app's package name, and you can go right there. So I have not shown any permissions in a manifest file until this point in the talk. Many of you are probably familiar with this. I'm listing 2 uses permissions in the manifest for this app: access course location, read context. You still have to put everything that you want, every permission you want in your app. You still have to list it here, regardless of whether or not you're going to be, or even though you're going to be prompting for it at runtime. It has to be declared up front as something you might use or you will use if the user allows it. The thing that I also put here that is noteworthy is this new uses permission SDK-M tag. This allows you to add permissions that are only there on Marshmallow and later versions of the OS. Why is that even useful? That's useful because you can not break auto updates of your old application, and it won't break auto updates on newer versions of the OS. So if you're updating your old one on ICS or Jelly Bean devices, they won't get that permission, but they also won't have blocked. They won't be blocked on the auto update. So can be useful. Not sure. I don't think we're actually using it right now. And again, going off the end of the slide here, some resources that I found useful when we were doing this migration and when I was putting together these slides. The developer docs, of course. The second one here is super useful. There's a sample app on GitHub, Google Samples. It's very little code, really easy to understand, really easy to build in Android Studio and deploy it and just play around with this stuff. That is, I would recommend everybody start there. Just look at that code. It's very little code if you're about to start working on this. And then, of course, there was a really good talk at Google I/O on the Android M permissions model. Some of it might be slightly out of date because they changed some things when Marshmallow finally released, but that's a really good talk to give you an overview. I think a lot of what I've said today is kind of similar to what they were talking about there. And finally, list of takeaways. Runtime permissions are better for users and developers. Thinks they're better. It's a much better user experience. It's hard to argue with that. For developers, it's better because you don't have to worry about updating your app. It's entirely opt-in. You can take your time. Keep building against API 22 or lower for the time being. You can do this at your leisure. But it is a good thing to do, as we've stated. Gate all your calls. Kind of obvious. Prompt users for access when they have the most calls. You can't prompt them at the time. Just gate the calls for now. And watch for security exceptions. That's all I have. Thank you, everybody. If there are any questions, over there.
So it looks like the context, permission check was a static call.
Oh, that's a good. So is the permission check a static call? It's a static call if you're using the compat library. The API also exists right on activity, so you can call it like your activity, whatever, dot check self permission. The reason I was using the compat call here is because that API was only added in version 23, so if you still want to run down level, you don't need runtime checks if you use the compat library, and it is a static call into the compat library. So, but you pass your activity context.
Right, but you said you had a mock version.
Yep.
So you weren't using a facade to go to the mock version?
We were in our code base, yes. In my examples, we're not using that. Is the facade and mock version open source? It is not open source. It's also very simple. There's not really doing much. Come chat with me afterwards. Any other questions?
How long do you have it out?
How long have we had it out? So there was a build available in the Play Store for Messenger and Facebook for Android, and I think Page Manager and Instagram and several Facebook apps at the same time when Marshmallow was officially released. So beginning of October.
No issues.
Yeah, for the most part. There may have been a stray security exception here, but I'm not 100% sure. It went fairly well, honestly. The fact that we were able to parallelize the effort and have a bunch of teams kind of building their pieces, it really helped. Yeah, it could have gone bad if it did. But the other thing is there aren't a ton of people using Marshmallow, right? So you can always count on the fact that a new Marshmallow won't be out, a new Android version won't be widely adopted for a little while until there's a brand new Samsung device. Okay, yeah. I don't remember what it's at now. It's not super widely adopted, right? If you have a Nexus device, you may have updated at this point. But I don't think anything but Nexus devices have it now. That might not be current knowledge. Are there any other questions? If not, I think it's lunchtime, right, Margaret?
Yes.
Or is it raffle time?
Huh?
Or is it raffle time?
We could do one raffle too before lunch. Thank you very much, Andrew. That was a great about the runtime permission. It's really complicated. We can do one raffle and a short announcement, then we can get the lunch. Lunch is ready. So just one quick raffle. Power bank. It's 53024. Jason. Great. Yes, I'll take that. Great, thank you. So, let's see.
We could have stolen this Bluetooth.
Oh, okay. Yeah, so the event isn't over yet, but I just want to quickly thank the sponsors and the partners. And I'd like to thank Hansmick from Disney for giving the talk, and Andrew from Facebook for just giving the talk on runtime permissions. And we have other sponsors and partners. OfferUp is out there. You can check out their booth. And then we have Big Brain Heroes, a nonprofit organization looking for mentors and coaches. So go check it out, and you can also check out the Cloudspin demo, so you can put your clip on Twitter. And food is here. Please enjoy yourself. Originally, we have scheduled the collab will start at 12:30. The site schedule change. Please come back here by 1 o'clock, and we'll get started with more instructions on that. Okay.